I'd like to welcome you to the third and final session of the workshop by Daniel Bolojan on AI. Today he'll be dealing with StyleGANs and CycleGANs, we shall be posting a video of this online, so you can go and have a check out later on. We're also live streaming on Bilibili and YouTube. So welcome everyone. And thank you, Daniel. Over to you.
Thank you, Neil. Hi, everyone. So this class then, or this last session, we are going to focus on CycleGANs and StyleGANs. So it's quite packed in a way, if you think about it. So I'm going to try to keep it something like 1.5 hours for CycleGAN, 1.5 hours for StyleGAN. Hopefully we can stay within that time. So right now what we are going to do, if previous time we looked mostly on in a pix-to-pix model, at a pix-to-pix model, where mostly what we did, we really tried to supervise, let's say, or to train the network in a supervised manner. Today, this session, we are going to mostly look at something like something like semi-supervised, let's say, and unsupervised model. Yeah. So CycleGAN, you'll see it's a very interesting network. Personally, I think it's one of the most interesting. Of course, StyleGAN, it's quite strong because of the output and also the architecture. But personally, I find CycleGAN very, very interesting in terms of the way it learns and the concept behind it. So what we are going to do today, mostly we are going to operate with images. Last time I showed you how we can play with, or how we can use Rhino and Grasshopper to generate our own data sets. And the reason why I was showing that option is because it's quite hard for you to find data out there that it's also labeled, yeah, to create this kind of like supervised, in a way, process where you say, you know, if it's a face, then everything I'm painting with a brush, let's say the nose, so that the network knows that everything that it's the color of that brush, it's a nose, and then the eyes with a different color and so on. To find something like that is quite hard, yeah? And it's quite hard to find that in architecture. So then the idea here will be, okay, how can we use then, can we use other methods maybe to create that kind of labeling, or what kind of other algorithms are there, yeah? So CycleGAN, it's a very interesting then network. If you remember in the very first session, we were talking about this idea of Van Gogh and perspectives, let's say, from nature. And what we were saying is that, you know, if you want to use a pix-to-pix, you need to have, in a way, the precise perspective from nature, and then to have the precise painting of that perspective painted as, you know, Van Gogh. And if you have those two, yeah, like the perspective from nature and the painting from Van Gogh that has exactly the same perspective, then you can say, okay, we are going to train a network to learn to translate from nature to Van Gogh paintings, yeah. So to do something like that is extremely hard, yeah, because you need like thousands of examples for a network to be able to learn. And then you end up having to hire maybe thousands of artists just to paint, you know, each perspective that you have from nature. And then you might say, yes, I'm going to have a network that is able to create Van Gogh painting, yeah. But what other option is there, yeah? So then CycleGAN plays with this kind of idea of, you know, unpaired data. So you have on one hand, let's say, images from nature, like perspectives from nature. And on the other hand, on the other data set, you have images of Van Gogh paintings. So the question or the problem that the network has to solve is, how do you translate from Van Gogh to those kind of nature perspectives? So that's a very interesting thing, yeah. But you can use those ideas then also when it comes to this kind of segmentation, yeah. And personally, I really like, in a way, engaging with networks in this kind of way. I don't like to engage with networks, just one network alone, yeah. I like to have multiple networks that that are supporting each other. And one network, it's performing one task, the other network is taking from there and continue doing something else and so on, yeah. So here, what we are going to try to do, the very first example, we are going to try to see how can we make, or some ideas how we can create segmentation, let's say, by using a CycleGAN, yeah. And then after we do that, I'm going to show like this kind of more, let's say, artistic or less supervised process where what we are doing, we are just selecting two collections of images, and we have a CycleGAN in a way trying to translate from one to another. Okay, so what I'm going to do, let me share my screen first. Share screen. Just like that. So right now, all of you, if you are participating in the workshop, probably you have access to the drive. And here in the drive, okay, you have your own folder, but then if you go out of that folder and where we have data sets and Grasshopper, yeah. So data sets, you'll see here we have some examples. So we have the examples that I showed last time, where you have this kind of pix-to-pix network that it's able in a way to detect. Yeah, it's able to identify based on labels that you provide. It's able to create a certain texture that represents, let's say, windows or columns or doors and so on, yeah. So now when it comes to this kind of idea of what if I don't have ways to annotate this kind of data, yeah? Is there a way for me to really create labeling without doing it manually? And one idea could be that you're using a CycleGAN to try to solve that question, yeah. And here, then I'm just going to show you a few tips, yeah. Like when it comes to working with this kind of networks, maybe some tips how you can play with the networks and how you can almost like control or manipulate the network to see things in a certain way based on the way that you're structuring your data set, yeah. So then here you see also we have other like data sets like mountains, we have slopes and so on. Yeah. So what I'll do now, I will just create a set of images, let's say, and then I would like to augment from there or to try to extract as many images as possible from a very large image. Yeah? So what we are going to do, the first exercise dealing with CycleGAN, we are going to look at satellite images of a city. And then what we are going to try to do, we are going to try to see, can we have a network that is able to identify buildings without us specifying exactly what's a building, yeah? So without us creating this kind of data set like you have here, yeah? Can we in a way ask network exactly what to look after, yeah? And why I'm doing this is because I think it's quite important for us to understand this kind of how the network is going to be influenced by the data set that we are going to generate, so that later then when you engage with CycleGAN and you start to pair this kind of images of nature, images of some other style or something, you understand in a way what's going on there, and you understand also how maybe to be careful with the way that you're structuring your data. Okay, so what I'm going to do is I'm going to, just for now, I'm going to increase the resolution of my screen just so that I can create some screenshots. So I'm going to go something like this, full resolution here. And probably for now, you don't have to do this. I'm just showing you the process, yeah? And then I'm going to save those images into a folder into our shared drives, okay? Shared drive. Okay, so I'm going to open here. I'm just going to go on Google Earth. And let's see, I'm going to just probably let's work with Barcelona, or which city should we work with? Yeah, let's just take Barcelona for now. So Barcelona. Okay, so what I'm going to do is right now on my screen, it's in high resolution. That means it's enough for me to just take a few screenshots like this, and then I can like create smaller crops around. So I can just take a few screenshots, and let's see, are they saving? So usually the way you can get a screenshot on Windows, you just press the Windows button and then print screen, and it's automatically saving it into the pictures location. So let's see if I can have it here. That's Earth, something else. Okay, let's see again. So right now we are just looking then at ways how we can generate data. Right now, previous class I showed you, okay, we can use Grasshopper or this kind of parametric tools that we have available to us. Maybe we use those kind of tools to generate data sets, then, okay, another method now will be, okay, we have this kind of screenshots, and then from those screenshots, how we go to creating a data set. And then I'm going to show, after this, I'm going to show, okay, maybe we take videos of something, and then we extract frames from that video, and then we have other images from somewhere else, So these are just ways how we can play with this and generate data sets, But it's very important to understand these ideas, especially data sets, because if your data sets are not interesting or are not very good, then for sure the outcome, you cannot expect that the outcome will be very, very good either. So let me just move these things around, because I see that right now on my screen, I'm also capturing the zoom. So let me just minimize these things here like that. Okay, move it up. Let's go back here. So I'm just going to move around this and just create a few other screenshots. Okay. Right. So I think that's enough. Right now I have 1, 2, 3, and 4. I have about 4 of them. So what I'm going to do now, I'm just going to copy now first. The first thing that I'm going to do is I'm going to just clean up a bit, because you see that I have this small menus around. So I'm just going to clean those images. Just open it in Photoshop, and we are just going to crop them. So for now, this is the initial step. I'm just making sure that this one is nice and clean. I have 4 images. That's not such a big deal for me to crop them this way. I don't have to create an automatic process for this. So I just can easily just do this. Just crop it manually for now. Just make sure you're just capturing information that is relevant here, and that's it. So all those kind of menus are excluded then from here. And I will do the same thing also for the other 4 images. So
Daniel, is your screen resolution is still high?
yes, right now my resolution is 4,000 something.
Because it's really lagging.
Okay, see. Okay, let me then reduce the resolution.
Thanks.
Okay, let's get back to full HD. Okay. All right. So then what I'm doing, I'm just cropping this, saving them. right, so I think I have all of them ready now. So I have 1, 2, 3, 4. Okay. So what I'm going to do with this, I'm going to copy these ones on our shared drive, so that you can also have access to them, and maybe you can download them from the drive then, and you can in a way follow together with me in the next steps then. Okay. So FIU, deep learning, data sets, and I'm going to say cities. Yeah. Like that. So, okay. So what I'll ask you to do is I'll ask you to copy these 4 images, to copy them onto your computer. And actually, wait a second, before we even do that, let's fix this issue with spacing. Yeah. Usually you should try to avoid having names with spacing in between. Yeah. Like if you have like that kind of spacing, then I just put another line or something. Yeah. And like that, it's better. And I will show you why is that. We are going to use some Python scripts that are not very happy with spacing in the naming, and neither they are happy with spacing in this kind of like links that you have source folders. Okay, so just wait a second. Don't download yet this. Let me just rename them like that. Okay, so now you can copy this on your computer. Yeah. So I'm going to do the same. I'm going to just copy this. Are you able to see the files? Are they uploaded, or we are still waiting for upload? Okay. Okay, so then let's wait a bit, yeah, while we are waiting for them to upload. Let's set up a few other things. So what we are going to have here, we'll have these big images, these large images, like quite high resolution. And what we are going to try to do is we are going to crop, in a way, smaller size images out of this, yeah? So imagine from 4,000, if we have a crop size, let's say of 512, we are going to be able to generate quite a few images, yeah? And we want to, in a way, create a sort of random crop around the image. So like that, we have different like samples of our data set, yeah? Now, another thing that it's important when it comes to data sets, you have to understand, and also to the idea of, I think you heard me talking about the model, how well the model is generalizing, yeah? So what we are referring to with that is, if I'm training, let's say, a data set with this, if we are training a network with a data set like this one, yeah? And let's say the network is able to predict correctly, yeah, when you show the same kind of images that you have here. Is the network going to be able, when you input, let's say, images of city of Vienna or something, yeah? If it's not, then what we are saying that the network is not able to generalize well, yeah? Is not able to like get as input any kind of information and to be able to predict correctly, yeah? So in that sense, we are saying the network is not generalizing well. And for us to improve, in a way, the network to generalize well, what we can do is we can, at the beginning, when we build up the data set, we can apply this kind of ideas of augmentation of the data set, yeah? For example, just to keep it quite plain, quite simple language, imagine that you have a network that has the task of identifying objects or a chair or something. Yeah. So what you can do is you can think of an idea and say, okay, what I'm going to do is I'm going to create, or I'm going to take a lot of pictures of chairs, and I'm going to put those pictures together, and those are going to be the data set that the network is going to use to be able to learn how to detect a chair from other kind of objects, yeah? So what could happen there is that it could happen that most of the pictures that you took are, let's say, from a certain perspective or certain angles and so on, yeah? So then the network is able to learn within those constraints that are intrinsic in a way, or, intrinsic in a way to the data set, yeah, that you put together, yeah? And for us to improve that network and to make it recognize better chairs, what we can do is we can say a chair that is oriented, let's say from left to right, it's the same chair also if we orient it the other way around, yeah, if we have it from right to left, yeah. So then what we can do is we can easily just flip or flip, mirror in a way the image, yeah. So similar with this, yeah. So right now if I were to just flip this image, suddenly I'll have an extra image that I can use to generate my data set from, yeah. So like that, in a way, I can show multiple of these kind of conditions to a network, and the network then it's able to expand more potential, in a way, scenarios, for this kind of city or that kind of chair, yeah. If you think about it also, if you're flipping an image upside down, then it's also something plausible, because it might be that sometimes a network is going to look at a chair that's upside down, yeah, and still the network has to recognize and understand that chair, it's actually a chair, yeah, even if it's upside down, yeah. Otherwise, if you don't give those kind of references, then the network is just going to recognize objects that really are like in the correct position, yeah. So that's where we can play with data augmentation, yeah. We can play with the data augmentation to really improve the network ability to learn better, yeah, and to also generalize more. Okay, so here, for example, then we can easily just flip those kind of images, or we can rotate them, and then from there we can crop and so on, yeah. So we have these big images, yeah, and what we are going to do is, while the upload is ready, we are going to create this kind of crop images, yeah, of 512, let's say 512. Okay, and then these images, this 512 resolution, we can move things around like this, yeah, and we can crop or have different parts of this this city cropped like this, yeah. Okay, so that's what we are going to do next with the augmentation. So let's see, this is really 512, no. Okay, so let's have it 512 exactly when we crop. So resolution 512. Yeah. Okay, what's going on? Why I don't see the resolution? I want to see pixels. 512. Yeah, for some weird reason, it's keeping it always just square. It's just maintaining the ratio. Anyhow, it's fine. I'm going to show that just in a second, yeah. So while these are uploading, then what we are going to try to do is we are going to create, or trying to play with the CycleGAN to see, can we create segmentation of this image, yeah? Can we create maybe a network that it's able to detect, let's say, it's able to detect buildings from streets and from greenery, let's say, yeah? From this kind of trees, yeah? Are we able to do that, yeah? So what we are going to do is we can easily create certain patterns in Grasshopper or other kind of softwares that will give us, in a way, this kind of information easily, yeah? So what we can do is we can just open Rhino, and we can try to generate, in a way, this kind of grids that somehow, resemble, they don't have to be exactly the same, but somehow resemble similar shapes, yeah, like the ones you have here. Yeah, so now you don't have to necessarily do this in Grasshopper. You can also just follow, and then I'm going to share the Grasshopper definition with you. So what I'm going to do, I'm going to import the image here in Rhino just to see it as a reference. And then we are going to play a bit with a few things here to see how we can generate things. the resolution is a bit off, but yeah, it's fine. Okay, let's go back here. So I'm going to import one of those pictures. And in my case, where do I have it? I have it here. I'm going to just bring it here. Just for us to have it as a reference like this, yeah. Okay, so now here in Grasshopper, in Grasshopper and Rhino, what I'm going to do is I'm going to try to generate some grids that are quite similar with this shape of the buildings, of the building blocks, yeah. So I'm going to go here, and these are, what are these ones? I'm going to really just treat them as quads, yeah. I'm going to say grid. I'm going to create a grid out of just quads, squares, yeah. Just like that. Let's see where we have it. And then what I'm going to do is I'm going to scale those down a bit to allow space for streets, and then also those kind of courtyard moments I'm going to create. Okay, so usually what I do is I always start with very small resolution things like this, and then once I have everything set up in Grasshopper, then I just increase the resolution. Yeah. So for that reason, I'm just going to create now that amount of cells that I have there. And then let's see. So another thing that we can try to do is we can try to match more or less the scale of things. Yeah. So here it's another trick that you can think of when it comes to CycleGAN. Yeah. So you'll ask a network almost like to look at this image and then look at images or images, yeah, like this, that have a very similar shape. Yeah, let's say like that. And you have a lot of arrays like this. And you're going to ask that network to figure out how to map, this kind of information onto this kind of map here, yeah? So what's important here to know is that if I'm asking the network really to do this kind of translation, and this translation from this domain to this domain, it's quite close, yeah, because I have quite the same scale. I have the same scale of this drawing here, yeah. Then it's going to be much easier for the network to really perform that translation. If I input for the network something that is super small, like this, for example, then it's going to be much harder for the network to figure out that actually what you mean by this kind of very small shape, that you mean something like that, yeah? Yeah, so here I'm talking literally about, almost having a hatch, yeah, a color information like this, and you're just asking the network to look at something like this and then be able to generate a sort of segmentation for this image, yeah? So here then the first point here is that we have to understand that a CycleGAN data set is going to be impacted in a way by the way that the CycleGAN network will learn. It's impacted by how well the data sets are represented, and then how close they are to each other. Yeah, if they are very far apart, probably it's going to take longer for the network to really learn and to be able to perform a specific task. Yeah, if they are more closer, then it's going to be much easier for the network. Now, another thing that's important in the same kind of discussion, yes, so one topic is the scale then of the drawing that we are going to have here. Yeah, so that scale, it's important. And then another topic that is important is our ways that you can make the network learn faster or make it easier for the network to learn. You can also try to slightly match in a way the coloration that you have here. So if we are looking here as humans, for us, we are not identifying necessarily the shape of things, and not based on the shape we are saying that's a building, yeah? There is a color pattern in a way that it's in this image that creates this kind of shapes, yeah? And then like that, we are able to differentiate between this is a street and this is a building, a rooftop, and then you have some trees around, yeah? So then what we can do is, instead of just using this kind of black hatches, we can actually try to have a very similar color like the rooftops. Yeah. So once you do that, it's going to be much easier for the network to figure out and to learn what you are trying to ask that network to learn. Yeah. In this case, you are asking it to look at this image and based these kind of references to be able to create labeling in a way. Okay. So I'm just going to go here, just change for now the color, other, and let's say we have something quite close. Not like that, something like this, yeah? So once I have something like this, and I'm saying to a network, look at this kind of images and try to translate and create a sort of segmentation of this, you'll see it's going to be much easier for the network to learn, yeah? Okay, so these are some tips in a way that will save you like time on, trying to create the perfect data set without knowing in a way which are the factors that are really influencing the way that the network is going to learn, okay? And then the street, yeah, if we have a street here, then the street is going to be treated with that kind of gray, and then we are going to have some trees around, yeah, that we are going to play with, okay? So let's see, let's go back here. Is this still synchronizing? Yeah, seems like. Let me just disconnect it first and see if it's going to go faster. Drive. Yeah, let's just wait for it. And in the meantime, then we just work on this side. Or is there another way for us to share very fast with everyone? Can I send these images in the chat here? Is there a way to send image in the chat? Can somebody help with that?
Not sure, to be honest. Let me see.
One way is maybe WhatsApp.
Let's see.
Neil can send us that.
Yeah, I can forward it.
Yeah, but WhatsApp is going to lower the resolution.
Okay.
So that is not really helping. Anyhow, let's just continue then with the Grasshopper. Yeah, we are going to build up a sort of Grasshopper, a small script that's going to create this kind of variation of these kind of shapes. Yeah. All right. So here we just have a very basic dot grid, and we are going to try to mimic similar shapes like we have with a building footprint. Okay, so I'm going to scale the grid down a bit just to have the almost like the courtyard. But first, before we even have the courtyard, we have to create just the outer outline of the building, just like that. Yeah, so like this, we have that kind of separation between those. Okay, something like this. And let's say the courtyards, then we treat them something like this, yeah. And we can also have it randomly generated because, as you can see, many of these, they don't have exactly the same shape all the time, yeah. So we can also create a random factor there, yeah, random. And the random is based on how many of these grid points we have. So I'm going to just find the length of it. Not like that. Actually, that's fine. So number is that, and then just randomly going from, let's say, 0.5 to 0.7. Yeah. So now these are like scaled. Each one of them, it's slightly different. Yeah. So we are just creating extra variation now. So another thing then, if we still want to have this, maybe we can also suggest these kind of ideas that we have here. So you see what I'm trying to do, I'm just trying to, in a way, deconstruct a few main features that I can, as a human, I can understand in this, yeah. And by doing that, my hope is that the network is going to be able to train faster and be able to detect faster this kind of shapes, yeah. So I can also create a chamfer, yeah. Chamfer, no, fillet. Okay, let's do it with fillet then. And we have a certain radius that we can use to affect that, yeah. So this is very large now. Something like that, okay. Okay, and now our things that we have here is we have from time to time these kind of diagonals that are also cutting through, and they are creating this kind of like almost like triangular kind of blocks. So we can also try to see how we mimic something like that. So the easiest way for me, like what comes into my mind right now, maybe it's something like this: boundary box. And I'm going to create some random points, populate 2D, no, populate geometry like that. And here I'm just going to have 2 points, yeah. And let's see, based on those points, I might get a direction, yeah. Polyline. So I'm going to get this kind of random directions, yeah. Then I'm going to use these random directions to cut through, yeah, to those objects. Okay, so what I'm going to do first, I'm going to extend. So make sure that that curve is quite long. We can, yeah, we'll do it like this, so that it's really intersecting. And the same also the other one. Yeah. So like that, we know for sure that it's intersecting. And now what we can do is we can just, let's see, create an offset. Yeah, I'm trying to keep it as low as possible when it comes to the types of components that I'm using, so that we don't have to install also extra Grasshopper libraries now. Okay, so we are going to keep it like just Grasshopper, like basics in terms of components that we are using. Okay, so we have this, and this is going to create an offset. This offset is quite big, so let's have this one smaller. Something like that. And we do this in both directions, yeah. And then we can use that one to just left for now. And then let's see if we can region trim or region difference between our grid of cells that we have here, but the scale ones. Yeah, this one with this one. Okay, so now that's giving us those kind of blocks that are trimmed like that, yeah. And now we can easily just scale down so that we have those kind of courtyard conditions. Okay. Oops. So this one, it's a bit quite messy, but the reason why it's quite messy because we have to find the centers. Let me just close my Teams. Quit. Like that. Okay. Okay. So now we have something like this, yeah? And the idea will be that every single time when we generate a new variation or something, then that line it's cutting differently, yeah? So if I have a very large number here and I start to change that, yeah, I can have easily then these kind of different grids that are being generated. Okay, so that's the idea here. Okay, and now for the sake of being able to go to the entire example, I'm going to limit in a way I'm going to limit a bit the number of images that or the size of the data set that we are going to generate, so that only that we can move faster. Yeah. Okay, so that's one. So right now, let's see what other. I mean, these ones are going to be a bit tricky to design, to build. So what I'll say is perhaps I'm just going to create some. I'm going to create some grid that it's scaling up and down a bit. Yeah. So for example, if this grid is like this, I'm going to have it scale area and have it randomly scaling, random. In one direction or the other, yeah? So let's just hide for now these ones. And we can have this one randomly scaling like this or on the other direction, yeah? So therefore then creating something, a very similar pattern like you have here. Okay, and now here, this one, it's a bit more irregular. And because of that reason, probably we are not going to just use a polyline like we did in this case, yeah? We are going to have maybe something else. Okay, so let's just go very fast through this. So here we are going to have a length based on how many cells we have. We want to generate random values like that, yeah, and like that. Okay, now we can constrain this so that it's not going to 0. It's always, let's say, that size, and then this one also, and then we can have them actually bigger, yeah, so that they start to intersect, yeah, and maybe the other direction, less or not, yeah. So once we have this, now we can easily say region union like that, and we have nicely just the outlines, yeah, of those intersections, yeah. So in a very similar fashion, then we are going to maybe change the seed of the random, and based on that, we are going to create this kind of like moments of some intersections, some streets, like more something like this, yeah. And you see, it doesn't have to be perfect, exactly that, yeah. But this one is not this one for sure, yeah. So when you look at this, the qualities that you have here, they are not the qualities that you have here, but they are closer to the qualities that you have over here, okay? All right, so now the other thing that we have to do is, in the previous example, I was doing it with this kind of extension curve, yeah, to create this kind of main streets, yeah. But here we have this kind of more curvy, in a way, streets. So let's see if we can do something very similar. So I'm just going to copy this entire part here and put it down. Just like that. And now I'm going to use this one. But because we are working with this kind of streets that are a bit more curvy, what I'm going to do is I'm going to, instead of having just a straight line, I'm going to try to see if I can have something a bit curvy. So because of that, I'm going to create 3 points, yeah, instead of just 2. Initially, I just had 2 points. Right now, I'm creating 3 points. And then instead of polyline, we are going to use an interpolate line, just like that. And yeah, so that will give us then this kind of, let's say, streets curvature. Yeah. Now this one, it's not the main street, so we are going to make sure that it's smaller, yeah, like that. And then we are going to do the same thing. We are going to intersect this with our initial grid, yeah. So this one intersects with this one. And when we display it, we are going to have something like this, yeah. Okay, so I'm just describing now, yeah, in very general terms, the types of conditions that I might have here versus the type of conditions that I have here, yeah. Okay, so now once I have that, I can just apply color to it, yeah. So boundaries, boundary surface, just like that, or not even that, but let's see. Okay, that one, it's fine. And then on this one, we can create a mesh. So usually I create a mesh only because if I apply color onto a surface, that color might have a glow to it, yeah. So it's going to be a bit glossy or something, yeah. So in order to have the color very matte, yeah, very without any reflection, I'm just using a mesh, yeah. So then mesh colors, like that. And I'm going to color this mesh like this. Okay, but now the color of this mesh is going to be very similar maybe with what we have here for the rooftops, yeah. So let's try to match that, or at least roughly to be closer, yeah. So we can use this picker here. Is it allowing me to? There you go, yeah. So maybe I just choose something like this, yeah. Accept. And the same color we are going to use also for the other one, yeah. So copy paste. I can have it here. Let's see. Okay, so these two, we can combine them. So I can say here graph, graph, graph. And then I'm going to have one list. For those of you that know Grasshopper, I'm just going to create one list on that has the inner and the outer curve of this building block, yeah. And then from there, I'm going to create this kind of boundary, yeah. And once I have that, then I have nicely a surface generated that way, okay. Is that making sense for everyone? Okay, so I assume that's a yes. So now the other thing that we have to do is we have to figure out a way how to, so the street is going to be the background, yeah? So the background, then it's fine because we can keep the background a certain color. And then when we output this information as an image, it's going to record also the background, yeah? So we don't have to create necessarily the street, yeah? But we do have to create, in a way, this kind of trees. So let's see how we can create those trees very fast. And then once we are done with this, then we are able to generate the data set, yeah? Okay, so let's go back to the basics again. So what we have here, so this is our initial grid over here. And then we are scaling that grid down, yeah? We are scaling it down. And then from there, we have this kind of like outline of the buildings, yeah? So what we need here, we just need a sort of offset of this, yeah? Almost like a sort of sidewalk. And along that sidewalk, we want to just populate and add some trees, for example. Yeah. So what I'm going to do then, so first I just have to find the actual outline and the one that is already with fillet, yeah, like that. And then I'm going to offset this, yeah, offset inwards or outwards, yeah. Let's see. Something like that, yeah. So you have all the shapes. They have this kind of sidewalks, yeah. And then once we have this, we will just have to create a surface between these two, yeah. So loft, and then we are going to add random points on that surface, and those random points are going to be considered then trees, okay. Not merge. What I'm trying to do, this one with this one, but it's not happy because it needs to have exactly the same structure, like 0, 0, yeah. All right. There you go, yeah. So now we have this surface, and on this surface we can create, again, random points, like similar with these ones from here. Okay, so I'm just going to copy paste and use it over here. And now we are going to create more of these points, yeah. Okay, and once we have that, I'm going to just create some like tree canopies or something, yeah. So this is going to be a circle. We are going to create circles, and the circle radius can be randomly generated so that we have a larger variation there. So length, yeah, and then we can change also the variation based on this seed value from here, just like that. And now just the radius of those has to be quite small, yeah, because the scale of things here is very, very off right now. So let's keep all the trees above a certain value. Oops. Okay. Now what we'll have to do is we have to crop in a way the ones that are intersecting. Yeah. So first thing I'm going to do, I'm going to just create a region union. So all the ones that are intersecting, they're going to be region union. They are going to be in one shape in a way, just like that. Yeah. And now we have to exclude the building. Yeah, the building footprint. Okay, so now this one is kind of, it's going to slow down our simulation. So let me just decrease this to have less trees like that, yeah. 25. Okay. So that way we have less trees. And then what I'm going to do is we have to crop the trees according to the outline of the building. So region difference, just like that. So from here, and these are the buildings, yeah. So now we just have to make sure we have a very similar structure so that we don't distort things too much. Okay, so this one, simplify. That's fine. And then we're going to use this one. Okay, so like that, then we just have these shapes that remain outside, yeah. So right now they look a bit funky, yeah, if you think about it. But I mean, we can also look at other options how to generate these points. But for now, I'll say let's just leave it there. Okay, just for the sake of this exercise. Okay, so now what we'll have to do is we just have to create or to give a hatch or a color to this kind of trees, yeah? So let's see how we do that. So we can use the same kind of logic. So we just copy the mesh and we are going to convert automatically the curve into a mesh like that. Okay, and then we are going to use a color that it's much closer to a tree. Okay, so set, and we are going to pick this. Oops. And we are going to pick this kind of green. Something that way, yeah. Okay. So now we have this, yeah. So on one hand we have this, it's working fine, and then we have the buildings, yeah. We have a sort of trees, and then we have the background, which is going to be the street, yeah. So the background, yes, we can build it like we can really do it like this in Grasshopper. So I will just move it down just so that things are not overlapping, geometrically speaking, and then you get weird results there. So I'm just going to push this one down in the back, and then we can do the same thing here. We can have a color preview. Can have a color for this, yeah. Something like that. And that's going to be the color here. So you see now when I am applying that color, because you have the rhino that has its own like sun system or something, or some lights, yeah. You see that this gray is not really gray, it looks like white, yeah. So that's why I prefer to have it as a mesh most of the time, yeah, because then I don't have that issue. So let's put it there, and mesh color, just like that. Okay, so this is going to be the color. Okay, so now if you remember last time what we did, last time we also, now here you see in this part, you see that there are not so many trees, yeah? So in this case, I'm just going to leave it like that, the other way it is. So I'm just going to leave trees for this part, yeah? So if you remember last time what we did, we just created a floating viewport, and then we start to, we really used exactly this crop here. We set the viewport exactly there, and then from there we start to save images, yeah, for our data set. So I'm going to do something like this then. I'm going to use the human plugin that I share with you. So we have viewport screenshot or screenshot, just screenshot. Okay, let's see how I find that. Save viewport, maybe. Yeah, save viewport. Like that. Okay, and what we are going to do is we have to create a floating viewport, new floating viewport. Oh, come on. Floating viewport. And yeah, and we are going to use this viewport then to have it exactly the size that we need for that kind of image. And we are going to create another one because right now we have both. Yeah, we have also this, the one that has this kind of more square, like quadrant in a way, building blocks. And we have also the other one, yeah. And the other one right now it's just sitting like that, yeah. So what we want to do is, if we are running this simulation, we want to run everything, or if we run this kind of simulation of these kind of designs, then we want to do that at the same time. Yeah, I don't want to run this one twice. So then what I'm going to do is I'm going to move this one. I'm going to move it to the side on X direction. And I think I have to do it by a factor of 10 or something, or even more, yeah. Okay, so factor of 10. So now what we'll need here, we just need a sort of outline so that we can easily position correctly the viewport. Yeah. So the first thing, let's create the second floating viewport. So we have two of them, yeah, like this. And what I'm going to do is I'm going to save. Now, first I'm going to change here the resolution, yeah. If you go to display or properties display, you're going to be able to see for each viewport, you have a way to input values, yeah. So 512, let's go with 512 because it's not going to take that long to train. And the same I'm doing for the second one, 52, it's 512, like that, okay. Okay, and now what we have to do here, we have to just create a boundary around this, yeah, so that we can zoom in correctly onto this, yeah. First, we also remove the grids and all the axes so that we have everything clean, yeah. So the same applies also in this viewport, just like that, okay. So we have the viewport very clean. Okay, so now what we can do, we can easily just bake the bounding box. If we can do that, no. So let's just bake the grid, just like that, yeah. And this is going to be the way that we are going to use them to zoom in correctly, so that we have this exactly within the boundaries of the viewport, yeah. So I'm just going to zoom selected, yeah, and then you have the option to zoom by a scale factor, right click, and you zoom by 1.1, and that will give you exactly the perfect location, yeah, in the viewport there. Okay, so that's that. And now what we can do is we can also do the same thing for the second option. So 20, no, it was 10, minus 10, like that. And then here we are going to have the second one and zoom by scale factor, and there you have it. Okay. All right, so once we have this, now we can just save these files, yeah, well, not the files, but the viewport. That will be good to have, name views, and then this is P1, let's say, and the other one is P2. P2, okay. There you go. Now, when we are going to save these images, we are going to use the save view, yeah, and we are going to save, let's say, about 200 images, yeah. So we are going to create a loop. If you have Anemone installed, so start loop, and then loop, like that. And then each loop we are going to add one, so +1. And then here we are going to do this for about, let's say, just 400 images. And this one, the counting is going to start from 0. So I just have to input then -1. Okay. So this one now is going to generate for us a series of numbers from 0 to 400, yeah? Okay, and we can use exactly the same value now just to loop through the seed, yeah, the random seed, to create different kind of variations, yeah? So that's what I'm going to do there. So we can also use a Boolean here to stop the loop manually, like that. Okay, so first thing, let's save. And then we are going to continue. Okay, so my drive, share drives, FIU, data sets, and I'm just going to drop it here, yeah? City labeling.
Daniel,
Yes.
quick question. Do you think it's better not to have an outline for the building blocks? Is it going to read them better, or are we just speculating?
So here, the exercise that we are playing with here, we are saying, the previous class I was showing this kind of pix to pix, yeah. So you have paired data. You're really saying, okay, if the building has this shape, then this is, or if this is a building, this is the shape, the outline of it, yeah. And you're identifying exactly the outline of that building, yeah. So the problem here is that, yeah, you cannot do that with all the data sets, yeah. If you want to analyze something for a city, for example, you cannot do that. You cannot just annotate everything manually. And there are other ways probably, but they're not that easy to work with. So then what you are doing here, you are just trying to get like a sort of very rough way of identifying and labeling the city, yeah. So in that sense, then you're not betting on precision, yeah. You're not betting on precision because either way, it's not going to be, the result is not going to be something extremely precise. It's just going to be a sort of rough map identifying, what that is, yeah. And in many instances, that's enough, yeah. You don't need to have all the details of the building. So that's why, in a way, I'm fine with having these things a bit sharper, even if the edges here of these blocks, they are not that sharp, yeah. Okay. So that's the reason behind. So what I'm trying to do here, I'm just trying to walk you through a sort of my thinking process if I were to, let's say, do something like this, yeah. So that everyone kind of understand how you can approach a problem and how you can address and how you can create the data set for the problem that you're trying to solve. Okay, so we have these two viewports. So now we are going to just save them, yeah. So first here we have to define if the viewport is set to true, then it's going to save the viewport. And then here, which are the viewport names, and here we are going to input P1, P2. So just going to be like that, P1, and set multiple actually, P1 and P2, okay? And then here we have to specify the location to save the images. So I'm going to use a location on the drive. So in that way, I don't have to wait to also copy things there. So file stream, shared drives. And where is it? FIU, this one. And data sets. And I'm going to call this one, I'm going to say this is city labels. Okay. So that's going to be the location. And then we have to attach the name of the file, yeah, to it. So in this case, we are going to have two files that we want to save at the same time. We want to save also this one and also this one, yeah. So because of that reason, we are going to have two files, and somehow we have to differentiate them, yeah, to create a distinction between the two. So one is going to be named, let's say, yeah, quad Q, yeah, like that. And the other one is going to be something to just normal, yeah, just a number. Yeah, so this one is going to start with Q, and then we are going to add the number and extension PNG. PNG. Yeah, so the number, we are going to get it from here, from the loop. PNG, and this one has to be .png, just like that. Okay, so you are going to have Q 372, let's say, yeah, and so on. Okay, and then the other one is going to be without any letter in front or something. Or yeah, let's just put a T, like traditional or vernacular, let's say, grid. Okay, and these two, then we are going to combine them, and we are going to use them as the output locations the save perspective or save view, which is this one here. Okay. And this one, yeah, is just going to trigger if we are saving the viewport or not. Okay. So now, before I do that, another thing that I'm going to do is I'm going to go back to just 200. Because if I have 200 iterations and I'm saving 2 images at the same time, then I'm ending up with 400, yeah? Okay, so that being said, let's turn this one on. And let's go and start the loop here. So first we are going to reset the loop, and then let's start it like that. So let's check here if we have, yeah, these images, they are uploading here. So do we have P and Q, or yeah, we have both of them, T and Q. Yeah, so we have this kind of images that, let's say that these are the labels that we are going to use for that. So turn on the icons. Okay. So display, you mean the icons like this, the grasshopper icons? Yeah, but either way, you should be, you should have access to this on the drive. So let's see, is the drive still creating problems for us today, or yes, kind of. So I'm going to do it like this. I'm going to create a WeTransfer, and I'm going to send the WeTransfer into the chat, into the meetings chat. So like that, you're going to be able to download from there the 2 data sets that we just started to work with. Okay, so data sets, cities, and city label. So for now, I think I just have to wait a bit. I just have to wait a bit for the labels just to make sure that we have everything there. Okay, it's already done. Perfect. So I'm just going to bring down also that folder here. Add more files, folders, and city labels. Okay, and I'm going to also add the grasshopper file, okay, that I just worked with. So let's save it. Then not this one. Like that, okay. And I'm going to open this. Open. Get link. And I'm going to send the link, okay, in the chat.
Daniel, can I ask you a question while we're waiting for this? I'm just thinking that like if we're gonna use these data sets that you just produced for CycleGAN, I mean, it seems to me that it's very much like you're controlling, again, like in terms of like, it seems to me that it's more maybe for peaks to peaks. So the way that you're producing your data sets, because it's so controlled in a way, it's so supervised, versus like, let's say if you were using an image of like sets of images that they were showing like green plants around the rocks, then the network could predict based on those type of images. But this way you're really instructing it to what the network to see in a way. I don't know.
Yes.
Does it make sense?
Yeah, so here, so we have this problem, yeah? So the first problem with peaks to peaks, we are saying we want to be able, let's say, to look at this kind of colors, color labels, and the network should be should understand those labels and then create those kind of facade patterns, let's say, yeah, or create new facades based on the labels, yeah. So that's one problem, yeah. then let's say that what you want to do the process exactly the other way around, yeah, because the problem there with Pix2Pix is that you cannot manually label all that information, yeah. I mean, you can do it, but it's just that it's a lot of effort, yeah, to do that, yeah. And then the question is, okay, can you have a network that is doing that for you, yeah, the labeling? So if you want to have a network that it's able to do the labeling, then you have to instruct it in a way how to create the label, yeah. So you cannot just show, let's say, images from nature that have similar colors like the city, like the satellite image, and then expect that the network is going to actually create that kind of translation, yeah? Because a CycleGAN, at least, it's able to understand the composition of the image, and then it's going to look at images from nature, and it's going to impose the composition onto the satellite image, you know? So like that is not going to be able to actually segment and in a way, yeah, segment like buildings from streets from green, for example, yeah? So why I think it's important, this step, is because then later when you're going to work with this kind of images from nature and images from with city, let's say a satellite image, then you're going to understand that it's not just about like just drawing one data set here, another data set here. You have to know what you're looking for. If you're just speculating, then yes, of course, you can just input whatever data that maybe you find interesting, and then just figure out in a way what the network is going to learn from there, yeah? But if you want to, in a way, say specifically, because we are dealing with architecture now, let's say that you're looking at images of sales or something, yeah? So for you, then you'll start to understand that the images that I input with sales is very important. They are very important and they are very crucial, yeah, for the network to really look at those images and translate into something that maybe it's meaningful architecture, yeah. Because otherwise, if you just input whatever images, you're going to end up with a result that it's very could be that it's interesting, but you cannot really say that really has some architectural quality in that sense, yeah. It has a quality in a very speculative, and I'm fine with that too. I'm not arguing that we should go against that. I'm just saying it like, you know, if we want to control, if we want to in a way be more intentional, then we have to understand that these data sets, they are very important, yeah. It's the same like the idea of this kind of colors and the colors that you have in the rooftop. It's almost like I'm biasing the network to look for the things that are important for me to look for, yeah. You know, because otherwise, if you just throw it there, yes, it's going to learn something, but it's not learning what you want that network to learn, yeah. And then how do you judge the result of it, yeah.
Thank you.
Okay, so I think probably my connection is very poor, maybe because I'm streaming in the same time and everything it's uploading here. Okay, but once this one is done, right now we are about 1 hour and 20 minutes in, but once this one is done, then we should be quite fast. Actually, we can go over the CycleGAN, how we set it up. So I don't think we are actually that far behind right now. Yeah, so here's, you have to understand this kind of ideas of data sets. Like, also you have to see like what exactly I'm trying to translate, yeah? If you remember, there was the original example of the CycleGAN. It's presented with this idea of translating from a horse to a zebra, for example, yeah? And what? Zebra to horse. Yeah, so let's see, CycleGAN. Yeah, so this is the original paper, yeah? Like you're translating from zebras to horses, yeah? Now, the reason why this, it's very successful is because if you look at it, the shape of things, it's very similar, yeah? The shape, it's very similar of both, in a way, domains, yeah? And that makes it very easy then for the network to really have a nice translation and to really like also then have videos. We can have a video of a horse and it's automatically converted into a zebra. Yeah? So if you aim for this kind of ideas, like similar with what we are doing right now, then yes, it's your interest in a way to have these things quite close to each other. Yeah. If you want to go further and speculate, and I'm doing the same thing like with some projects. Yeah, I'm really speculating and just combining different kind of data sets that normally you say they should not be combined. Yeah, and then you end up with super interesting results from there too. But then it's still a question of, okay, I have, let's say that first iteration that I'm running an experiment of a random data set and another random data set. Yeah. And now I just let the network to figure out and to output something maybe that it's interesting. Yeah. So you're going to have that. The network is going to be output something that it's interesting. But now probably you're going to say, but I would like to enhance maybe these characteristics a bit more than the other ones. Yeah. And then the question for you is like how exactly you go in and really enhance those characteristics that you're interested in. Yeah. So then suddenly you go back to, okay, I have to look at the data set and understand how that kind of characteristic is represented into my data set. Yeah. And then maybe you run a second experiment and probably the result is going to be closer to that idea that you have or something. Yeah. So this is the idea here. Yeah.
Actually, can this is really fascinating, like the preparation of the data sets. Even in this example that you're showing, like zebra to horse, do you think what is the data set that was able to have this sort of zebra pattern, not outside the horse, and just make sure that it's inside the body of the horse?
So let's see if we can find so here for this data set was a bit easier, only because I think it was a bit easier only because the shape of those two are quite, it's quite similar. Yeah. So you look at it, roughly this was the data set. Yeah. It looks something like this. So now this one for sure, personally, I'll say that's not really a data set. Yeah. Probably whoever built this is not really, didn't do such a great job. But if you end up with this kind of images, yeah, this is a horse, yeah, you have a sort of background, yeah, you don't have that much noise, and then you have zebras that have quite similar background, then yeah, you'll expect that the translation is going to be more successful. Yeah, if you have it with this kind of more complicated, more complex in a way backgrounds, and that will make it very hard for the network to really understand and to sort out in a way all that noise. Yeah. Let's see, can I find somewhere the actual data set? I think this one. So let me check first. Are we still waiting for the WeTransfer? What's going on with the WeTransfer? Everything is slow today. Seems like. That's something else. I'm not going to go into that. Anyhow, but if you search for it, you'll see there is the original data set, yeah, that was used for this project when they published first the paper of CycleGAN. Okay, so what I'm going to do is I'm going to stop my sharing only because something happens. Yeah, probably my connection is not that good, and the streaming, like the screen streaming, is probably eating everything. Okay, so let's just wait a bit for it to upload. Yeah, so here, these are like topics that I think is very crucial for us to understand. Yeah, especially if we are not in a workshop where we go into technical things of exactly the architecture of the network and we build things up like that. So then it's very crucial. The way that we can control things is by how we manage and how we curate the data, yeah, and how well we understand the data that we curate, yeah. I mean, there are other like ways to do this that probably we are not going to go into today. Like you can create. There are different machine learning algorithms that will help you to cluster data and to understand how well you are representing a certain domain, yeah, how homogeneous that data is, and so on, yeah. And those are different methods, yeah, that you can use then to really make sure that whatever domain you're trying to represent, to make sure that that domain is actually represented correctly, yeah. So if you show in a way images, let's say of waves crashing, yeah, into stones or something, yeah, if into rocks, sorry, if you have that, then okay, the idea will be to try to constrain that data set only to those kind of examples, yeah. You don't want to show then also backgrounds like the city silhouette or something, yeah, because that information is not relevant to the type of task that you're asking the network to produce, yeah. So if you're looking also, if you remember Memo Acton, Gloomy Sundays, or how it's called, also there he's playing with this kind of like, you know, fire and water and what have you, yeah. But for you, in a way, to be able to have that translation so clean and to have water and fire so clean, you really need to have, in a way, the data set of water and fire quite clean, yeah. You cannot include noise, yeah, behind, because that's making things, in a way, messy, yeah, and the network probably is not going to be able to learn that well. Okay. Yeah.
Dan, I have a quick question, Daniel,
Yes.
in terms of CycleGAN. When they use, let's say, the networks that take photographs and turn them into Van Gogh paintings, assuming that you can have a lot of photographs to put in, of landscapes to put into the network, but you only have a limited amount of Van Gogh paintings, or maybe you want to make it just to look like Starry Night and you only have the one painting. Do you create the data set to train by just using the augmentation, as you said beforehand, kind of multiple crops and taking from points, or how else could you generate a large enough data set from just a single painting?
Yeah, so from a single painting, if you have, if the painting is high resolution, then yes, I'll do something like that, yeah. I'll really try to crop, in a way, that image as much as I can, yeah, different kind of zones of the image, and then try to train the network in that way, yeah, in the hope that somehow will also, by showing those kind of small local examples of the painting, the hope will be that the network will be aware then of the global general, in a way, picture in the end, yeah. All the, you know, all the features that you describe like that with the data set, you know, because the data set in that case is just representing one image, yeah. It's just that you break it into smaller bits, let's say, yeah. So something like that I will try for sure, yeah. And then what you can try also to do is like to perform, maybe you don't have the crops being that small, yeah, because that's one way. Let's say augmentation is, I'm just cropping the image at a smaller size, yeah. And like that, I end up with 1,000 images from one image, let's say, yeah. But probably that's not always the best solution. And this is depending on the task that you're trying to perform, yeah. So in this case, maybe it's not the best solution only to have a crop function, yeah. It could be that what you can do is to augment and to have a lot of data. It's just, you know, you crop, let's say, at a larger, with a larger region, but then you start to slightly rotate and maybe flip the painting, yeah, upside down, sideways, and so on, yeah. Or maybe you can start to stretch it a bit, yeah, because even if you stretch it, the style is still there, yeah. The relations that you have in that painting, they are still there, yeah. It's not like you're distorting those relations. So maybe those kind of operations then will allow you to have a bigger crop while still increasing the number of data points that you have in your data set, yeah. So this is what I hope to do now after the upload it's done. We can go over this kind of example of augmenting, yeah. We are going to look at the images of Barcelona. We are going to crop them, augment them, and then use them as data set. And then we are going to look at other example, like images from nature, maybe with images from Barcelona city, like satellite image, you know. So those will be like, in a way, some methods, yeah. But here it's always, and this is what you have to be very careful with, it's always, which is the task, yeah, what exactly I'm trying to solve with this, yeah. And not necessarily like what I'm trying to solve in a very constraining, pragmatic way or something. It's just that, okay, I'm trying to translate Van Gogh to this kind of nature paintings, yeah. So then that's the task that I'm asking the network to perform, yeah. So then how can I create a data set that is going to be very suitable for that task, yeah. So if I'm cropping in very small regions, then probably that's too much, because you're just capturing some detail, and maybe this kind of more broader, in a way, features that develop on larger crops or areas, they are not going to be represented well. So then, you know, I have larger crops, but I have distortion, maybe, yeah, distortion in the painting, and I have rotations, and I have flipping, and so on, yeah. So if you think just about cropping and rotating and flipping, you end up from one image, you can generate 8 images, yeah. Because imagine that you can flip upside down, you can flip left, right, you can flip upside down, and you can rotate 90 degrees. You can flip left, right, and you can rotate 90 degrees. And then you can rotate the 90 degrees that was flipped, and so on, yeah? So you can end up with eight variations of the same crop, yeah? And suddenly you have a larger data set, yeah, like that, you know? So this kind of methods, yeah, you have to think of it, then, yeah, that's maybe a better solution. This kind of types of augmentation techniques, let's say, are more important than just to have a smaller crop, yeah, you know? So that's why I'm saying it depends on topic. For example, if I'm saying that I have buildings and I'm looking at nature, and I want in a way to somehow extract from concepts from nature, or, you know, compositional concepts from nature, and somehow influence architecture, or create an architecture that is influenced by those kind of concepts, then whatever data set I'm creating with buildings, the buildings, they have to have the skies up probably, or the images. In the images, the buildings, they need to show that the sky is up or down, yeah? If you want to do it intentionally the other way around, then yes, you do it intentionally, yeah? But if your goal is to have some buildings that look like buildings, let's say, yeah, then, for example, one rule will be there. I cannot create a data set for the buildings, at least for the buildings domain, that has the skies down, yeah, because I started to flip upside down the images, yeah. And then suddenly you're limited to a set of augmentation techniques, and you're saying, okay, I'm just going to flip left, right, and I'm going to maybe stretch a bit the images, yeah, because I cannot flip upside down, up, down, yeah, you cannot flip that, you cannot rotate it, because then you have it on the side, yeah, the sky is somehow on the side. So then you're left with this kind of like, you know, flip left, right, and then stretching or distorting a bit the image, you know. Okay. I don't know how exactly we can do this. It's funny how we expect all these online things to be faster. And if this were to be a in-person workshop, I'll just copy everything on a stick, and, you know, by now everyone will have everything. But yeah, this one is I'm still waiting for it. I think it's just the fact that I have so many smaller images, and probably that's why it's taking a lot of time to put it together.
Can I ask a question, Daniel?
Yes.
Okay. Which part of the process is the training and which part is the testing? We are exporting images from Grasshopper, and then we have other images from Google Maps, and then using GANs will do a process. And which part from this whole experiment is the training and which part is the testing? Thanks.
Okay, so right now we are just building up the data set, yeah. So once we have the data set and we put it together, then we are going to go into a training mode, yeah. So we are going to go in the training phase, and after, let's say, 200 iterations where the network was able to see the data set 200 times, then we go into a testing phase. Yeah. And the testing phase is just meant to verify if the network actually learned correctly something. Yeah. And that will be all. Yeah. So right now we are still held back here by the data set generation. Yeah. But once we are done with this, then we go straight into the training mode. Yeah.
So we decide that we just finish the training mode when we can recognize the generated images and so on. But
yeah, so that will be right now. This kind of GANs, let's say, you cannot really say that just by a number value, because if you're looking at the way that the network trains, you have some loss functions. Yeah, and the loss function is almost like the distance from, you're saying that this is an image correct, or the image is fake, or the image is real. Yeah. And the more you are able to predict or to say which image is real and which one is not, the lower that rate is. Yeah. And the other way around, then a generator will be like, the more you are able to generate images that are crossing, like, or are passing the test of being real and not fake, the better. Yeah. But for you just to evaluate that as a human, just to say, I'm looking at that number, and based on that, I know that the network was able to learn, it's quite limited, because we are looking at certain, like, visual aesthetic information. Yeah. That we are, based on that, we are evaluating things. Yeah. So then the way that you are doing that mostly is like a subjective manner. Like, it's a method where you're just looking at the results and you're assessing the result, and you're saying, I think that right now the results are quite good. Or you can have also other objective methods that are structural similarity index, for example, or perceptual similarity. So those are like other methods that can help. Yeah, but they are not going to identify, still they are not going to identify qualities in design. Yeah, they are just going to identify maybe how close, how real, like, those images are. Yeah, but not really quality of design. So the quality of design is still something that you as a designer, you're the one defining that. Yeah. And then if you are saying, no, I don't like the quality of design, or aesthetical features that are expressed here, I'm going to let the network run more, perhaps. Yeah.
Okay.
So it's that kind of assessment. Yeah. At this point.
Daniel, I've got Memo's Gloomy Sunday video.
Okay.
Can you show
Can you
it?
share it? Yeah. Yeah. That would be great.
Okay. It's very beautiful. Okay, ready? I want to share my sound as well. Let me show the sound. Okay.
Sadly, one Sunday, I waited and waited with flowers in my arms for the dream I'd created. I waited till dreams like my heart were all broken. The flowers were all dead, and the words were unspoken. The grief that I knew was beyond all consoling. The beat of my heart was a bell that was tolling. Saddest of Sundays. Then again day when you came to find me, they bore me to church, and I left you behind me. My eyes could not see when I wanted to love me. The earth and the flowers are forever above me. The bell tolled for me, and the wind whispered, never. But you I have loved, and I bless you forever. Last of all Sunday.
Do you think how many networks is being used for this, Daniel?
For this video from Memo?
Yeah.
I think he's mostly using CycleGAN. And now it depends now how he's creating it, but it could be that he created first the video that you have on the left side, and then trained with those frames from the video, trained in a way the pairing with the fire and with the water. Yeah. And it might be that what you're looking at is mostly just post-processing. I don't think it's real time. That thing is not running real time.
Yes. I also got the one that Fernando's one of the architectural version of that. Do you want to see that, or? Yeah,
that's fine. That's fine. So also in Fernando's case, we did a very similar thing. Like first you make a recording, a video recording on one side, then you extract the frames from that recording, and you use it as a paired, as an unpaired data with, let's say, images from Zaha in this case, yeah. And then you let the network train, yeah. And the network is training, and then afterwards, in testing mode, you take each frame from the video and you input it one at a time, yeah.
I mean, just to say that we're going to, if anybody's interested, we're going to be talking about that on the, there's a session on AI and neuroscience as part of the theory course on the 14th of February. On the 13th of February on Digital Futures, Refik Anadol is going to be presenting his latest work as well. So kind of back-to-back sessions. Okay, thanks.
So here, Ahmed, I think you're asking about, it would have been nice for this to be 3D. So here's the same, like for me, it would be the same kind of idea is like, you have the type of data that you have, yeah? And the idea is, yes, it would be great to have this one in 3D, but how do you make it 3D? You cannot scan, you don't have the access to Zaha's buildings, like the 3D Zaha building, yeah? You don't have the 3D geometry of the t-shirt that you're playing with in the other side of the video, yeah? So then what you can try to do is you can try to say, okay, I have this is the data set that I have, so then I can use maybe a network that's going to help me to just address this aspect, yeah, and then I'm using other network that is going to extract maybe some information and it's going to create a sort of 3D of it, and then other network that is performing something else, yeah, and then you combine these three together, let's say, and then you end up with something that is 3D without you having the actual 3D data for it, yeah. So in many instances, I think these are the challenges, and also that's why there are a lot of different kind of networks. They are trying to solve these kind of problems from different kind of angles, yeah. So instead of trying to scan then everything and to try to use to train networks in that way, you have other methods then. What I'm going to do is, because I don't think it's good for us to really just waste time now on waiting for this upload. What I'm going to do is I'm going to show, at least on my screen, I'm going to show how we connect those things to the data sets, how we augment the data and so on, yeah? How we connect the data set to the CycleGAN and so on, yeah? And probably then in the meantime, probably the upload is going to be complete, and then we can do it also on your computers. Yeah, so to avoid then this just waste of time, yeah, when I'm just sitting and not showing you how to do things, I'm going to share my screen, yeah. I'm going to show the demonstration on my screen then, how we augment things and how we train then the network from there on. Okay, so let me share my screen. Okay, so what I have here right now, I have the data set, yeah, the two data sets that we were trying to work with. So this set of images from Barcelona and the city labels, I have them in two separate folders at this point. So what I'm going to do is I'm going to, right now we have these ones, yeah, the labels, let's say they are already in the right format. We don't have to augment them, although we could do that also, but we don't. Oops. So here, as you can see, there is an issue here. So the way that I generate the data set is not actually changing anything. So probably I forgot to connect. I forgot to connect perhaps, yeah, this one to the slider. Okay, so it's good that I just observed that. I'm just going to run it, and in the meantime, we are going to run the augmentation process. So let's just put this one here, like that. And I'm going to run this again. Okay, so in the meantime, then I'm just going to go in the other folder, and I'm going to show you how we do the augmentation for this, yeah? So right now we have four images, and somehow we have to end up with 400 images, yeah? So what we'll do here, we can already think of it like this, like we have 400 images. So from these 400 images, let's say roughly 50 maybe are going to be used just for testing, and the rest 350 are going to use for training, yeah? And the reason why we are doing that is because we want to have like 50 images that the network is not presented with during the testing, during the training, just to make sure that the network was able to learn once you input completely new images, yeah? Okay, so that means that here from these four images, we have to be able to generate 400 images. Okay, so last time I showed, and I think you already downloaded the data management tools from last time, yeah. So last time I was saying that we have here a data management tools, yeah, these ones. And here you should be able to have, you should be able to see this augmenter folder, yeah. And into this folder, then this is the script that we are going to run to augment and to generate 400 images out of these images that we have here, yeah. So let me see where I have that on my computer. I think it's somewhere, is it in downloads or where did I have it? So, not that one. Agent based, something else. Okay, let's just, I'm going to copy that here. So I'm going to copy the data management tools. I'm going to copy them in this location. Okay, so I'm going to open Anaconda. We are going to work with Anaconda. So the first thing that we have to do here, we have to get access to the folder where Anaconda, where Auto Augmenter is located, yeah? So if you go into data management tools, and then you go to Augmenter, you have, this is the location, yeah? So we have to set the current directory of this Anaconda. We have to set it to that, yeah? So CD space, and then input the location, yeah? And now you're going to have your location there. Okay, and now what we have to do is we have to open this file, yeah, right click and open. So now if you have other more fancy editors like Notepad+, you can open it with Notepad+, or you can just open it like this, yeah. Okay, so here what you're going to have is you're going to have a code that you'll have to interact with, unfortunately, yeah. So here what you'll have to do is you'll have to go into your data set where you have the 4 images, yeah. So you have these 4 images of Barcelona, and we are going to copy that location where these images are, yeah. And we are going to paste it over here, inside here, yeah, like that. In case that you have spacing in this path, you have to put in front of columns, yeah, in front of quotation, you have to put an R, yeah, in case that you have spacing in the name. Okay. So now here, what you see, what you probably have too, you have something like this, yeah. So now here you can also delete some of these ones. Here I was just, you know, augmenting things like in mass, like not only like cropping with a fixed size, but also scaling down the crop. So like that, you know, you augment and you have even larger data set, yeah. So I'm just deleting these ones then, yeah, just to have it clean. Okay, yeah, that's fine. Okay, so here then you see the first option, let's say we have it's cropping, yeah. What we want to do is we want to crop at the resolution of 512, okay. So for that, what I'm going to do is I'm going to turn off this line, yeah. So what you see here, if you have a hash in front of the line, that means that line is commented out, meaning that the script is not going to read that line, yeah. So if I can comment out this by just creating a hash in front, yeah. And then if I remove that, now this line is going to be active, yeah. So here, if you are looking at what this command is saying, it's saying probability. So probability means if probability is 1, for example, that means all the images that are within this folder are going to be cropped, yeah. If the probability is 0.5, then only 50% of the images from here are going to be cropped, okay? So that's what the probability is, yeah? Then you have the width, and in our case, let's go with 512 only, 512, and the height, yeah? And then it's asking you if you want to center, yeah, the crop. So if you center the crop, and you have to be careful with that, if you center the crop, that means that it's going to center the crop at the center of the image, and it's just going to crop that, yeah? But if you want to have a crop that is jumping around and cropping randomly around, yeah, the image, then it should have this set to false, yeah, false with capital, yeah, just like that. Okay, so let's continue now down this code. So what I'll do for now, I'll just leave it like this. Yeah, first I'm just going to create a crop, and I'm going to then define how many images, like by what factor you're augmenting the images. Yeah, we have 4 images right now. Do I want to end up with 40 images? Do I want to end up with 100 images, or how many? Yeah, so my assumption will be that here we have 3,900, yeah. So we have 3,500, and we have almost 2,000, yeah. So that means we have 4, yeah. We have 4 by 8 crops, yeah. If you were to crop the image into regions of 15 by 15, you'll have on this side you'll have 4, and on this side you're going to have 8, yeah. So that's pretty good, yeah. That's pretty good, because that means per image we can end up with 36, yeah, no, 32, sorry, 32 images, yeah. So 32 multiplied by 4, we are at 128 only by, you know, by having this kind of random crop, or not random, but if we were to split this image into crops of 512 by 512. Sorry, I'm super tired, seems like. All right, so let's say that instead of having 128, let's say that we have something about 200, yeah, 200 images. Okay, so I'm going to input here. I'm going to comment out this, yeah. So if you have the P process on, what that will do will create exactly the same number of images that you have into your data set right now, yeah. So it's going to crop these images, and it's going to output just 4 images, yeah. But if I want to have more than that, yeah, like we have right now about 200, then you go to the bottom of the script where you have the P sample, yeah. And here inside the P sample, within the parentheses, you just type in 200, yeah, and then you save. So it's important for you to save, like Control S, yeah, save. So then once you have that done, yeah, so we have the location to our 4 images, we have the crop size, which is 512, and then we are going to randomly move around this crop region and crop the image that way, yeah. And then we want to generate 200 images out of that, yeah. Okay, so now once we have this, here we have to type in exactly the name of the file, yeah, of the augmenter file. So again, if we go to Data Management Tools, Augmenter, the name is exactly this one, yeah. So we have to type in something like this, Python, and then space augmenter.py, okay, and then press enter. So now this one was able to find for him images there, and now it's creating those 200 images, yeah. So if I'm going back into my folder here, you see that an output folder was created, yeah, and within this folder you have 200 images, just like this, yeah. And you see that they are random crops of those big images, yeah, that I just saved. Okay. All right. So once we have this, now, yeah, once we have this, we can, I prefer to do something like this. You see, always when you work with Augmenter, so the initial name of the file was screenshot32 PNG, and now you have a very long, weird formatting, yeah, like a sort of ID of the file, yeah. So because of that, I don't want to go further to augment this data and not change the name of this, yeah. So if you go back into our data management tools, you'll have here a rename path, yeah. So this one is going to just give you a set of instructions like how, where to, which are the files that you want to rename, yeah. So if you double click on this, you'll see that these types of files that you have here, they are asking you for specific information, yeah. So for example, here is saying the source location input, yeah? Where's the location, the input located, yeah? So in our case, we want to rename these files that we have in this folder. So I'm just going to copy the location of the folder and paste it in here, yeah? And then press enter. And then it's going to ask you which is the start count value. So I'm starting counting or renaming from 0, or I'm starting to rename from a different value. Yeah? So why that will be important is because if you already have, let's say, 200 images and you want to add to those 200 images another 200 images, then probably you want to rename from 200, not from 0. Yeah, because then when you put everything together, you have like files with the same name. Yeah. So then starting, it's going to be from 0. And this is going to be a PNG, yeah? So just PNG file, just tapping the extension and then press enter. And you'll see now here, it's going to update, yeah? And you have all the files nicely renamed, yeah? With a nice formatting, yeah? So this is what the rename bat is doing, yeah? So now I'm still short 200 samples in this data set. Yeah, right now we just have 200. The other data set has 400. So let's see how we can further augment this. Yeah. So I can take this location now. Yeah, exactly the location from here, and now change that into the augmenter. Yeah, I can add it here. Yeah, or even like just add, I can also either just typing it like that. So output. Yeah, just like that. Okay. So now we are going to go with inside this output folder, and we are going to augment like this. Yeah. So we don't have to crop anymore the image. Yeah. We already cropped the images. The images are already 512 resolution. So I'm going to comment out this. So let's see now what other, in a way, processes we can apply here. So what I'll do is I'll make it a bit more diverse. Yeah. So as you can see here, this is a city. Yeah? If this image is flipped or rotated, it doesn't matter. It's still describing the same city. Yeah. So it doesn't matter like the north, for example, in this case. Yeah. If we have the buildings correctly oriented with the north arrow up or something or not. Yeah. So because of that reason, then I'm just going to apply here a few methods of, let's say, flipping left and right and flipping bottom and top. Yeah. So I'm going to go here and I'm going to uncomment. Yeah, I'm going to erase or delete that hash. And now here you're going to have the option to flip left and right active. And what I'm going to do is I want to create 200 samples, but I don't want them all 200 to be just flipped left and right. Yeah, I want them to be quite mixed. Yeah. So because of that reason, I'm going to really have these two 0505, yeah. So then more or less 50% of the images are going to be flipped left and right, and the other 50 are going to be flipped top bottom, okay. And here you see you have also other options to skew and to distort a bit your the image, yeah. So you can bring those or make them active. Then you also have options to distort when it comes to color, yeah, like the brightness, the color of the image and so on, yeah. So you can play also with those things, yeah. But here, for example, if I were to have a task which deals with detection or something, yeah, and let's say that the network or whatever needs to be detected, it's in a certain environment that has a light that is changing, yeah. If that will be the case, then the way that I'll augment the data will be based on this kind of probably, you know, contrast and color and brightness and so on, to create almost like to simulate different types of light conditions, yeah. And like that, the network will be able to learn correctly, and it will not matter if the light is changing in the space, the network will be able to predict afterwards correctly, yeah. So this is what I mean, you know, like you just have to understand your problem, yeah, the problem that you're trying to solve with the network. Once you understand that, then it will be easy for you. It's going to be easy for you, yeah, to augment or to know which kind of steps you have to apply in this augmentation process, yeah. So in this instance, we don't really need this kind of contrast or so on, yeah. If you look at the images, satellite images, they are mostly all the time the same. They are not changing based on, you know, the daylight or something, yeah. So because of that, I'm going to keep it just like that, okay. So let's go down here. So here we want to generate 200 images. Yeah. Let's actually just do it for the fun of it. Yeah. Let's have also some skewing left and right. Yeah. But this one, I'm going to have it very low, just a few images. Yeah. 0.2. So let's save. Yeah. Control S, saving that. And now if we go back to our Anaconda over here. So now what we can do, we can repeat the last command. Yeah. If you press the up arrow, then it's just going to repeat the last command. Yeah. So you can go like that, navigate with up and down. Yeah. So if you go with arrow up, yeah, you could just go up towards the first input commands that we had here. And if you go back, yeah, with arrow down, you go back. Yeah. Okay. So let's just do this like Python augmentor, press enter. Okay. And now here you see that we have a new set of images. Now these images are rotated and some of them are also skewed a bit. Yeah. Okay, so now here what I'm going to do is I'm going to rename again these images. So let's go into where we have the dataset folder, data management. This one. Why is it not showing up? This one, okay. So let's rename, double click, yeah. And this is the location where we are going to, for the files that we are going to rename, press enter. And now here, because what the end goal will be that we are going to take these images and we are going to combine them with these ones from here, yeah. So these images, they are already going up to 200, yeah. So then what I'm going to do is I'm going to start the counting from 201, okay. So these ones are going to be renamed and they are going to start counting, or the file name is going to start from 201. Okay, so the start count value is going to be 201. Press enter, PNG, and then just like that. And now you have this one. Yeah, we can take now these images and we can put them in the same location with these ones. Yeah. Okay. Just like that. Okay, so what we are going to do now, we are going to try to build up our data set. Yeah, so let's say city or satellite to labels. Yeah, like that. Yeah. So now in the case of Pix2Pix, if you remember, Pix2Pix, we had to build up a data set that had a training or a train and a test folder. Yeah. That was the only thing that we needed there. In the case of a CycleGAN, we need to have 3 folders, yeah? 4 folders. So here, if you remember, we had slope to vector, you have test, and you have train, yeah? And in that, you had like both like sides, yeah? You had the first side of the image, like from where to learn to what to learn, yeah? In the case of CycleGAN, we are going to have 2 separate folders for these kind of images, yeah, because we are not dealing with the paired data. Okay, so the way that a CycleGAN data set will look like will be something like this. So you will have a train A, and you're going to have a train B folder, yeah. And this is going to be for the first like satellite images, and the other one is going to be for the images that we generate from Grasshopper. And then we are going to have a test A, and we are going to have a test B. Yeah. Sorry. So this is the structure of the data set. That's how it has to look. But now what we are going to do here, we are not really going to build up that data set manually in that way. Yeah? What we are going to do is we are going to use here another script here, set up training data set, that will help us to create automatically those folders and structure. Okay, So the first one is going to be, let's say we go with the city labels. We have, why do we have more? Okay, so here there are a lot of errors, seems like, in the Grasshopper. Okay, so I'm going to remove this then. Wow, there were a lot of files that we had to remove. That's okay. So what I'm going to do, it seems like the second window, this one, it didn't save correctly. So I'm just going to save that one alone, yeah. So I'm going to save just that, and that's P2. Okay, then while that one is still saving, we are going to do it for, okay, this one is not showing correctly. Okay. Just give me a second to see what's going on. Okay, let's do it this way. So I'm not going to wait for this now. I'm going to just, I'm just going to augment this data from here, okay? For some reason, this one is not outputting it correctly. Right, so I just stopped that one, and let's just do it like this, yeah? With the number that we have, I'm just going to augment this by flipping or rotating this, okay? So that way we have the same amount of images in both cases. So I'm going to go back to Augmenter, and I'm going to apply a very similar process like I did to the previous one. So I'm just changing the path, yeah. Then I'm saving, and now if I'm going back to Augmenter, to Anaconda, and then repeat the command, press enter, it's going to create now here an output folder with images that are rotated, or either rotated or squeezed a bit, yeah, like this. Yeah, you see these are actually, let's do just squeezing like that, yeah. I think that's better for this specific task, like skewing. Okay. So skew, and let's skew it also different directions like that. Okay, and let's repeat this. All right, so we have this kind of distorted grids, yeah, which are quite good actually. Okay, and now we are just going to rename this. So rename. And in this instance, I don't have to rename it from 200 because the other ones from here, they start from Q0, yeah? So 0 PNG. Okay, so now these ones are nicely renamed, and we can move them back to this folder, yeah? All right. Okay, so now we have 200 or almost 200. We have 2 extra that we can remove perhaps. Let's just remove like that. Okay, we have 400. So now we are going to set up the data sets, yeah? So again, we are going back to the setup training data set. Double click on it, yeah? And then it's asking you for the input directory. So this is going to be the input directory. And then it's going to ask us if you're working, for example, if you're preparing data set for a pix-to-pix, then you input here train, yeah? Right now we are dealing with a CycleGAN, so then we are going to say here train A, like that, yeah? And then test A, okay? Enter, and then here you can specify like how many of the images are going to be in testing phase and how many in training phase. Yeah, so let's keep it very like this, like 90% are going to be in a train folder, and 10% are going to be into testing. Okay, press enter. And now you'll see that a folder was created here, yeah, data. And inside the folder, we have the images properly placed, not so properly, seems like. I always mess up this. So it means that I think I input this one wrong here, yeah. So this one has to be subdirectory in the test folder, not train folder, yeah. So let me just switch these ones to, yeah. So this one, it's train A, and test A. Okay, like that. Okay.
Daniel,
so once, yes.
Can I ask a quick question here? What does it mean for the test folder to become like bigger? Like how does it impact your network if it's a larger data set for your test?
Well, it's not really a matter of larger. It's a matter of what you're trying to do is here, you have a data set. Yeah, let's say you have 1,000 images. So those images, you don't want to show all the images to the network. Yeah. Because the idea will be similar when you are in a class, you're teaching the student, let's say, certain concepts applied on specific scenarios, yeah? And during that class, for sure, the student is going to be able to tell that, you know, that he or she understands, in a way, the concept, yeah? But then during the exam, what you're doing, you're giving the student a completely new scenario, and the student has to prove that with that new scenario is still able to show that he or she understands the concepts, yeah, that were taught in the class, yeah. So the same happens also here. So in the training phase, we are giving certain examples or certain scenarios to the network, yeah, and we are asking the network to learn those scenarios and the underlying concepts of the scenarios, let's say, yeah. But then once that class, let's say, it's over, or that training it's over, the network has to prove now in a sort of exam kind of way that if presented with a completely new scenario, that the network is still able to actually describe correctly the concepts, or, you know, to prove that it was able to learn. So that's why here I'm splitting things into folders. Here right now it's just an error, yeah. So if you look at this and you see that you have 39 images into train A, it's just an error. Yeah. Next time I'll have to input here 0.1 instead of 0.9. Yeah. So the training set is going to be larger. The testing set is going to be smaller. Yeah. Okay. So here, for example, I'm going to have 39 in this case, and I will have 361 over here. Yeah. All right, so now what I can do is I can copy these folders. I can copy or even remove them from there, but copy, and we can put them already inside this folder. Yeah, satellite labels. So let's put them there, satellite label, just like that. Okay. So now we can do the same for cities here, for this one. Yeah. So we can take this folder that contains a data set and input, yeah. We are going to have now train B, because the other one was train A, and test B. And then we are going to have 0.1, yeah. And now 360 are going to copy it into train B, in test B for 40, okay. So we can copy now these two folders. We can copy them and put them into satellite to labels, yeah, just like that. All right. So now this will be what we upload on the drive, yeah. So you have this data set, and now you are going to copy that, and we are going to go into our Google Drive, where you have your networks, yeah. And in my case, I have it here, FIU. And I have it, I think, into neural networks, and I have it into CycleGAN. And then within data sets. Yeah. So you'll have to put this folder that I just copied, you'll have to put it into the data set folder from the CycleGAN. Okay. So just paste it in there. Okay, so now I'll have to again wait for this upload to happen. Yeah, but just to continue with the process while this one is still running, I'm going to go into our drive from the browser. Yeah, so you access now from the browser, and we are going to access our CycleGAN notebook. Yeah, so FIU deep learning, and then in my case I have it here, neural networks, and then you have here the CycleGAN notebook. Yeah, so double click on that, and probably for now we can start to set things up. Yeah, and hopefully in the meantime, hopefully the upload is ready. Okay, so here then you'll have your the CycleGAN. Yeah, so very similar with how the Pix2Pix Google Colab was structured. Very similar also the CycleGAN. Yeah, is structured. So you have a way to connect to your Google Drive, and then you have an option to install the libraries that are required for the CycleGAN to work. And then lower, you'll see that you have other parameters that are very, very, very similar with the ones from Pix2Pix, if not exactly the same. Yeah, it's just that it's a different kind of network. Yeah, so this is also a part of, I'm trying to keep my scripts in a way quite clean, so that I don't have to jump from one network to another and have completely different names and completely different ways of working with that. Yeah. So that's why here you'll see you have, for these two networks, they are exactly the same, yeah, the parameters. Okay, so let's see what's going on here. Yeah, my apologies. I don't know what's going on with the drive lately. Right now you see also my collab, it's freezing. The file and directory is invalid. So if you have that issue with when you run the rename script, make sure that you don't have spacing into your directory name, yeah, or into the link, yeah. If you have that kind of spacing, then it's going to give you that kind of error, yeah. Okay, so yeah, I'm trying to figure out what's going on, why right now my Chrome it's freezing or what it's doing. Okay, so I just pressed that cell, yeah, and in this case, it's asking me like warning because it was created outside of Collab, but that's fine. Just click on it, And now this one is going to connect. Yeah, it's going to connect to Collab and it's going to connect to the drive. So we have to specify or to allow permission for it to connect. So I have to copy then this link or this authentication code and paste it inside and then press enter. Yeah, make sure you press enter, because if you don't press enter, then it's not going to actually do it. Okay. Okay, so once we have that, then we are going to continue here. We're going to play the next cell. So you have to be careful, like, you know, always to play these things in sequence. Yeah. So the order of how you play these ones is important. Okay. Okay, so here then we have, like I said, we have very similar like the setup from the Pix2Pix, yeah. Only that in this instance we have to specify the correct location of the GAN, and in this instance we are working with the CycleGAN, so we have to point it to that location, yeah. So if we are going here to files, and let's see where my drive is, and then shared drives. So the same you are going to do also for you. You're going to really just open the location of your CycleGAN network. Yeah. So in this instance, it's over here, networks and CycleGAN. Yeah. And right click on that and copy path. And then you're going to paste it over here. Just like that. Yeah. And now here we have to define, like, you know, if you remember from last time, you have to define the experiment name and then the data set that you're going to use. Yeah. So here where you find the data name, so the data set should be the name that you define for that data set. Yeah. So right now I should have here like the data set that I just copied there. Yeah. But probably it's still synchronizing now. And that's why it's not yet there. Yeah. So I'm going to copy down just this name, yeah. And I prefer to really give the same name to the experiment with the same name with the name of the data set, because like that I can really know that this experiment is using this data set, yeah. If I'm running different experiments on the same data set, then I'm going to just add, you know, like that, experiment 1 or something, yeah. Okay, but always, you know, I try to keep track like which data set you use for which network. Okay. Now we are working with a CycleGAN, and because we are working with a CycleGAN is very, very heavy as a network. The reason for that being that a CycleGAN has 8 networks in total. Yeah, a Pix2Pix, for example, has 2 networks, a discriminator and a generator. A CycleGAN has 8 of them, yeah? So why is that? If you remember the example that I gave with translating from English to German and so on, yeah? So here what you have translating from English to German and from German back to English, yeah? So in this process, you have 1, 2 discriminator and you have 2 generators. One generator that is translating from English to German and another generator that translates from German to English, yeah? And then you have discriminators that, for example, this one, discriminator A, is looking at the distance between these two, yeah? The initial input and like the initial sentence in English and the translated back a sentence in English, yeah? So you end up with 8 networks, and that's why CycleGAN is so heavy. Yeah, what that will mean? It will mean that probably you're not going to be able to go above a batch size of 1. Yeah, that means the network is going to be able to just load 1 image at a time, and that also means, in special here on Collab, you're not going to be able to go to a very high resolution. Yeah, probably you're going to be able to go to 712 or something resolution, but not higher than that. Yeah, and even that probably with Google Cloud Pro, you're going to be able to get there. Yeah. So I'm going to keep the resolution the same. And now the other one is going to be load epoch. So this one, it's only when when we are continuing training. Yeah, right now we haven't even started the training, so we just leave it like that. Then we look at model parameters. So model parameters, again, we have the same kind of idea. Like if it's a ResNet with 9 blocks, then in a way the network has a larger field. In a way, it's able to view or to see relations that are further apart, yeah, than if you have it on ResNet with 6 blocks, yeah. Now, of course, if you are very, very sure about your data set and you understand that, you know, the two data sets are not that far off, yeah, the differences between them, then you can say, okay, I'm going to go with ResNet 6 blocks, yeah. But yeah, personally, I'm keeping it like that, 9 blocks. Now, the advantage of 9 blocks, 6 blocks is just that 9 blocks is lower than 6 blocks, yeah, because 9 blocks sees more, yeah, it's able to capture more relations than the 6 blocks. Okay, so then you have input channels, which again, they are referring to RGB. If you input an image that it's RGB, then you have 3 colors, yeah, 3 channels, R, G, and B. And then the same goes with output. In case that you input grayscale images, then you have to make sure you switch this one to 1, yeah, because grayscale has just brightness value, yeah. Okay, so here, because we cannot go higher than a size of 1, this one then is not, we don't even have to concern with it when it comes to CycleGAN, yeah. We are always going to use a instance normalization. The start count in this case is going to be 0. How often it's saving is going to be 100, and then how often it's saving the entire, in a way, network is going to be each 5th epoch, yeah. And then here you have the option to continue training, yeah. But in this instance, we haven't started the training. It's the first time when we want to run this network. So because of that, you disable that, yeah. If you have that enabled, then you're going to get an error, yeah. And then here the training parameters, pool size, it mostly refers almost like to, it's almost referring to an idea of short memory, yeah. But the idea here is that you're trying to have the network, the output of the network quite not constant, but more stable, meaning that you don't want to have a result that is jumping from something that is very not real looking, and one that is very real looking, yeah. So you try to reduce that oscillation with regards to the output, yeah. So you do that by really keeping in the memory of the network these 50 past images, yeah. So the network generated 50 images, and it's always or the network's, it's, let's say, generating now an image. That image is going to be saved in this memory, and then the network is going to continue to create the next image, and that next image is going to be placed in this memory, and so on, yeah. And you have always this kind of like 50 past samples that were generated in this way. Okay, so let's see. The drive, it's still creating for us problems. I think there are a lot of files that we're trying to upload and they didn't upload it properly, seems like. So now I'll just have to close them off, yeah. At least, you know, to be able to show you, really to show you on my screen how to connect to things, yeah. And then you can follow step by step. Does anyone know how you can cancel completely the entire like batch of images that are trying to upload now? Any ideas how you completely stop these files from uploading? Because they're just creating issues right now for us. Okay, I'm just going to go one by one like that. Are there some questions in the meantime? Because right now I really want to show also the StyleGAN, yeah. So once we start the CycleGAN and we can let it run, yeah, we can let it run like that. I can also show you the StyleGAN afterwards.
Okay, yes, I can ask a question. What batch size refers to?
So the batch size is like how many images the network opens at once or reads at once. Yeah. So what's happening, if you remember, in the case of pix-to-pix, not only GAN architecture, let's say. In the case of GANs, so what you have, yeah, this diagram. So what you have, this is your data set, yeah. This is your data set, and this is this is the generator, yeah. So when the training happens, what exactly is happening there is that randomly the discriminator is going to get samples from the generator or samples that are generated by the generator, and then also randomly is going to get images from real world, yeah, like, or from your data set, yeah, you know. So then how many images you are sending at once to this discriminator, yeah. So that's the batch size, yeah, you're inputting just one or multiple, how many, okay. So that's why then if you put multiple, yeah, it's going to be problematic for a CycleGAN because we have 8 networks, yeah, and then through all those 8 networks you have to pass those multiple images, yeah. So that's why that's problematic, yeah. So it's referring to this kind of images that are randomly input into this discriminator, okay. That's the batch size.
Thanks.
So yeah, let's see. So the batch size is going to help. It's going to help with the speed of training, yeah, but not necessarily. You cannot really say that it's going to impact like the quality of training. Yes, there was somebody asking a question.
Yes, Daniel. I was just gonna say, in terms of I think if you click the little gear icon for settings, maybe you could just click the pause syncing there, and it might just stop them from uploading. I don't know anywhere else that might help.
Yeah, but then it's pausing everything, the entire syncing, yeah? I cannot like copy now something else on the drive and just to have that part syncing, no? Actually, okay, maybe I do it like this and I just cancel, but no, I cannot cancel them. Yeah, I'm going to try to stop at least the ones that are very big. So like that, the other ones, the files that are quite small, those could upload quite fast. Yeah, anyhow. So this one, they could be stopped. Also these ones. Yeah, T25, Q25, right now they're uploading. So we should have our data set soon, yeah. Seems to be running quite fast now. It might be that we go slightly over the 3 hours that we had, if that's fine by everyone.
That's fine, Daniel. Fine.
just so that we can cover also the StyleGANs, yeah. I'm just going to wait a bit for this, yeah. Seems that it's working right now. Because then once we have that, I can show you how you start the network and how it's going to save things. It's very similar with the Pix2Pix, but yeah, it'll be good to show it, not only to talk about it. All right.
Daniel?
Yes.
Just to reiterate, so in this component, in the collab component, it's almost exactly like Pix2Pix in that we're just filling out the script with the information it requires, right?
Exactly.
Where you put in the data sets to run the test, and then we get the results out of this.
Exactly. Yeah, so in that sense, it's exactly the same. And also the parameters, you see that they are quite the same, almost similar, yeah. So that makes it a bit much easier to work with, yeah, if you have them quite the same. You just be aware, yeah, that if it's a CycleGAN, it's unpaired. If it's Pix2Pix, it's paired data, yeah. So that's the only thing.
The only difference, right?
Yeah.
Which is within the data set. Okay, thank you.
You're welcome. So this one is speeding up, which is good. We're almost done. We should be able to see, right now I start to see my data set here actually, in the Google Colab, which is great, because then once this one is done, I can start at least the training, yeah. So you see now I see the test A, test B, train A, train B. That's perfect. And it's almost done, yeah. I just have to wait a bit more for it and it should be done. Okay. So can you check to see if you go into your folders where you have your neural networks, yeah, like workshop participants and then your name and you have neural networks. Can you check if you have all those StyleGAN, the StyleGAN notebook and also StyleGAN interpolation notebook? That should be there too, yeah. And I think right now we should be able, yeah, to have those because the synchronization is almost done now.
Yes, I managed to open them.
Okay, perfect. Okay, so what I'm going to do is, now this one you see that it's still uploading. There are still a bunch of files there, but I think if I'm checking my drive, probably there are already enough, let's say, images for now, just to start a training for the CycleGAN. So let's say if I'm going here, CycleGAN, datasets, train A, 361, how many are here? 360, okay. So we can start the training of this, yeah? So, so then once you have all these settings done, yeah, then you just have to hit the play button here, yeah? Just click on it. Okay, so let's see, probably there's an error. Maybe we still have to wait for things. Do you have the same issue that I have? You see, I barely can scroll right now in Colab.
Everything is slow for sure.
Okay. All right, so let's see what's going on there. What I'm going to do is, in case that you have the same issue, like if this is what you get here, I'm going to just open the pix-to-pix scan, because maybe there is some error there that I didn't fix or something. Yeah, so I'll just expand this, like double click on it. Okay, so I'm opening the pix-to-pix. And I'm just going to copy that part of the code and put it into StyleGAN. We have to change slightly something there, but that's the fastest way, I think. Okay, so here, pix-to-pix. I'm just going to copy this into your chat, okay? So like that, it's faster. You don't have to open this. I'm just going to paste this in the chat. Just like that, okay? So copy exactly the thing that I send in the chat right now. Select everything here, yeah, into under training, select everything. And then I'm going to paste it like that, okay? And yeah, this one, then it's CycleGAN training. And then we have to also change here towards our line 37 and line 39, I believe. We have to change something there. Yeah, so here we have to change, if you move this bar here, we have to change here the model. It has to be CycleGAN, yeah? CycleGAN, like that. And the same also this one below, yeah? Make sure that you have the spacing here and afterwards, okay? So I'm going to, again, untoggle this continue train. And I'm going to go on here and just play this. And let's see if it's starting correctly now. Oops. Make sure that we change again the location of the network. Yeah, right now that location points to the pix-to-pix network. So let's make sure that we point to the correct CycleGAN network again. So copy path where you have your CycleGAN. And now let's start that, yeah. And here it is not slope to vector, is satellite to labels. And then we have the same here, like that, okay? Batch size, of course, we are going to have just one. And normalization, batch normalization, it's instance because we are going with just one batch size. And the start count is going to be 0. All right. So if I run this, let's see if it's running fine now. Okay, there you go. Yeah, so the network right now, it's loading, and then it was able to see 365 images in the training set. And now it's going to start the training, yeah. So right now it's a bit quite fast, yeah, because the resolution is not that big, and it's going to be fast also because the data set is not that big. But if we open the folder where that network is saving, Google Drive, shared drives, and deep learning. And then you have, in my case, I have it in neural networks, CycleGAN. You'll see here there's a checkpoint that is created called satellite to labels, yeah? And here you're going to have at one point some outputs from this, yeah? So we just have to wait a bit for it. You'll start to see some images being saved, similar with the way that you had it in pix-to-pix, okay? But right now, I think it's this battle, like Google Drive, which one to show, which one to synchronize now. These ones or the ones that I'm just uploading now. Okay, so I'm just going to terminate this one so that we are able at least, it might be that this is going to destroy the folder, or it's going to not copy certain things in some StyleGAN folders, but I'm going to copy them after the workshop is done. Then I'm going to copy again the StyleGANs there. So everyone, you should have the correct folders there then. Okay, so it's already started to save the network, yeah? So here we should be able to start to see samples anytime now. Let's see, let's go back there. Okay, so this one is up to date. So that means we should be able to see those there. Okay, I'm just going to let it run, okay? And then we can check it back after it ran for some time. Okay, yeah, so right now this is how you see the CycleGAN running, yeah? And then after that running, we are going to have the same kind of steps that we had also for the pix-to-pix, yeah? So you have the, to visualize the training results, and then you're going to have a way to visualize testing results, yeah? So when you are switching to testing mode, what's going to happen is that this script or the network is going to read now the information from the test A or test B, yeah? So for example, if you create this kind of like similar with what Memo or also Francesco did with Zaha and t-shirts. So what you can do there, you can then say on first hand, yeah, I have the video of the t-shirt or the video of this kind of everyday object, yeah. And on the other hand, which is the B, I have these kind of samples, examples of fire or water, yeah. So if you have in test A, for example, if you have every single frame in the correct sequence, exactly like you know how you have it in the video, and you have all those placed inside that folder, then you can have for every single frame of the video, you have a prediction, yeah. And then when you put things together, you have this kind of like nice animated in a way interpolation, almost like you know effect. But what's happening there in the end, you are just analyzing every single frame, and every single frame gets this kind of translation, yeah, like from fire or from everyday objects to fire. Okay, so that's how that is down there. Okay, so you might wonder like how you do that. If you check the data management, you'll see you have an option to extract frames, yeah. And I'm just going to show this one quickly just so that we are not falling behind even more. So here what you have, I also copied in the data set, I copied also a video from one storm chaser, I think. He's a storm chaser, Mike Blinsky. And he has this kind of very stunning, like 4K, 8K videos on these kind of supercells and storms. So let's imagine that you have that video, yeah? Let's say that you're taking a footage of everyday objects, yeah, similar with Memo or with Fernando. So what you can do is you can extract those frames, yeah? So let's say you're going to say pursuit. Yeah, I'm going to create a folder, and then I'm going to run this extract frames script, yeah? So this is going to ask me where is the folder where the video is located. So in this case, it's here. So I'm going to copy and paste that. And then the name and the extension of the video, it's pursuit and 04 MP4. And then where you want to extract, yeah, which is the folder where you want to extract. So it's going to be inside here. So copy that and paste it in. And there you go, yeah. So right now there are 13,000 frames there, which is quite a lot, yeah. And you're going to train now, you're going to extract the frames like this, yeah. And imagine that this will be then the data set or the images that you input into the test folder, yeah. And then when the network is reading the images from the test folder, for each image, which in this case it's each frame from the video, is going to output a prediction or this kind of translation. And then once you have those translations, I'm going to show you how you do with that afterwards. So let's imagine that these are all translations, yeah, that we already had the CycleGAN translating in a way from ocean to everyday object, let's say. How do you put those things together? Yeah, that's the next thing. So did I save that with you? Share that with you? No. Okay. Sorry. So I'm going to copy also this one on the drive. So data management tools, frames to video. Yeah, like that. So I'm going to copy that into our drive, and you can take it from there then. So just like that. And I'm going to put it here, yeah. Okay, so you're going to be able to find this script that I'm going to show now in there. So yeah, imagine that these ones that I have here, they are interpretations. So the testing process is going through all the images that you have in the testing folder, and then it's outputting an interpretation or this kind of translation from, let's say, ocean to everyday object, yeah? And the idea is then, okay, you can put these frames together in a video in After Effects and so on, but that's not very convenient. It's better just to have a small script like this, and you're saying, okay, image to video, you just double click on it, and then you have to locate where the frames are. So in this instance, the frames are here. I'm going to paste the frame location, press enter, then define a frame extension. In this case, we are dealing with JPEG. And the reason why this is important is because you want to encode correctly these frames into your video, and then press enter, and then it's asking you where to output. And let's output here, like that, data sets, yeah. And then it's asking you the name of the name and the extension of the file, yeah. So let's say this is test.mp4, yeah. So it always has to be MP4. So test.mp4, and then press enter. And now it's going to open a sort of window. You'll see one window popping up, yeah. And then it's going to stitch together in a way all the frames, yeah. And once it's done, it's just going to stop, yeah. Okay, probably right now the frames are too big and it's not running anymore. Or yeah, it's running. Yeah, so this is what it's going to do. Yeah? It's going to stitch back together all those frames, yeah, that you have there. Yeah, so this is Michael Blinsky. It's I really love what he's doing. has super nice videos like this.
Daniel, one quick
Yes.
question in terms of the authorships of the data that we're using, like.
Yeah, you have to be careful with that. I'm showing this as an example, but I'm not showing it as using it as a data set.
Unless it's, I guess, it's listed as a Creative Commons, right?
Yeah, yeah. And usually, especially if you do it as a project that is going to be published and stuff like that, I think it's always good to get in contact with the artist, yeah, or from whom you are taking. If you are using videos, yeah, it's always good to get into contact with those people. Okay, so this is how this one it's going to stitch everything together, yeah, and then it's going to just save that file in here, yeah. So the same, yeah, if you have your own video that you're filming at home, like everyday object something, or you have a video with a footage with a drone, yeah, and you have interpretation from, that kind of drone footage to something more interesting, let's say, then you can put together, all those interpretations in this kind of manner. All right. All right, so I'm just going to stop this because there are a lot of frames here. Okay, so it's not going to stop. Yeah, this one is going to run until all the frames are done. Okay, I'm going to let it run then. And let's just look very fast if we have some output from the StyleGAN. Yeah, there you go, from the CycleGAN. Yeah, so right now we start to see actually what we wanted to do. So for example, copy. So you'll see that now, even if we just started training, some of the results are quite good already. I'm just going to put it here on my computer so that we can visualize them better. Yeah, so this trick saved me probably hours, if not weeks or days of training, yeah. Only the fact that I started to be careful with the data set, yeah. So you see, it's already like from the very beginning, it's already able to recognize the type of color the building have and the labels that I was providing here, yeah. So this is the real image. This is the real image, yeah. These are the two domains, yeah, that we were translating. And now this one is automatically done, almost like mapping the urban space, yeah. Like these are buildings, this is a street, this is green, yeah. And you see also when it comes to green, you see that it's able to start to identify a bit that, yeah. And for me, these kind of things, of course, they feel maybe a bit not that much creative. But if you think about it, like we are actually, also when we are creative, we engage in a lot of processes that are not necessarily creative themselves, yeah. But when you put those processes together, then you'll end up with something that's creative, perhaps, yeah. So here is the same thing. Right now, we are just splitting in a way the entire process, let's say, into a tiny step, and we're just looking at this tiny step, yeah. Because here you can say that, okay, once I'm able to have this kind of segmentation, now I can train a network and let's say make this kind of urban spaces like a jungle, yeah. And I'm going to use a different network that is going to look at these labels and is going to encode now this kind of jungle aesthetics, let's say, where you have this kind of pink, and it's going to encode other kind of aesthetics where you have this kind of streets, yeah. And now you're able, in a way, you have access and you can control, and you can not only control, but you can steer, in a way, the interpretation of the network towards a direction that is, let's say, corresponds to what you're looking for, perhaps. Yeah. So yeah. Okay, so we are going to move on now. I'm going to let this thing run, yeah, and I'm going to move on to the StyleGAN. And StyleGAN, maybe many of you are most excited about, yeah, when it comes to StyleGAN. It's able to create some very, very intriguing, in a way, results. But like I said, for me, CycleGAN, I find it like, a more elegant, learner than the StyleGAN, yeah. In the sense, I think it's almost only because I see so many similarities with the way that we as humans learn, and CycleGAN. That probably that's why I really like more the CycleGAN. Yeah, the StyleGAN then. So we were dealing at the beginning, yeah, last class or last session, we dealt with Pix-to-Pix, yeah, and Pix-to-Pix was supervised learning, yeah. So we are specifying for this kind of facade, you have this kind of labeling, yeah, and then the network learns the label versus the type of patterns, pixel patterns that you have on a facade, yeah, and like that is going to be able to tell this is a window, this is a door, or this is a column, and so on, yeah. So that's supervised learning. Now, what we tried to do today was mostly a sort of supervised, but it's not really supervised. Yeah, it's a unsupervised learning. It's just that we are, by controlling the data set, we are kind of steering the network in a certain direction. Yeah. So that's the CycleGAN. Yeah. And in the case of CycleGAN, you can like ask or show the network two completely different domains, and without any of this kind of guidance that I showed today, can just ask it to just learn, yeah, just figure out the relation between the two domains, yeah. Now, of course, the results are going to be amazing, probably not necessarily, yeah, because for you to have super amazing results from that translation from a very random, let's say, just urban formations versus or favelas, let's say, and then you have on the other hand, you have trees, let's say, yeah, or these kind of canopies of trees, yeah. So for that kind of translation to be successful, it cannot be just random, yeah, random favelas and random forests. You have to control some of that data set. You have to remove like elements that are not really representing a forest or a favela, yeah, because yeah, you want to create that kind of translation so that suddenly you have to curate the data, yeah? So you still end up with a sort of process almost of supervision, but it's not supervision in the sense of how the network will learn, yeah, so that's the CycleGAN then, yeah. It's mostly unsupervised how the network learns, yeah, but you have a way to influence the learning of the network by the way that you are playing with these two types of data sets that you input. Okay, and then we have the StyleGAN, and the StyleGAN is the one that you just have to give images to, and it's going to learn from them, yeah. It's going to try to learn the representation of the images that you input. Now, here the same, I would say, the same kind of rule applies also here. So you cannot just throw images at the StyleGAN and hope that the StyleGAN is just going to learn, yeah. I think you have to be careful, like you cannot just combine images of cars and images of faces and then images of buildings and so on, yeah. If you do so, then also those images that you input of cars and buildings and faces, probably they have to be very well curated, for the network to really be able to learn. Otherwise, if you just input random images, sometimes you have people, sometimes you don't have people, sometimes you show the car as the main point, yeah, or the main focus point in an image. Probably that's not going to be helpful, yeah. That's not going to help. Okay, so then here what we'll have to do is mostly we just have to create a data set that has a certain resolution, yeah, and that's all, yeah. And then you just input that to a network and you ask the network to learn the representation of that data set. And once it's able to learn, and the truth is that StyleGAN is really capable to learn and really it's able to give you access to features of those kind of data sets that it's learning on. And then you can control and you can tweak and you can play with those kind of features. Yeah. So from that perspective, it's super, super strong. Yeah. Because it's really giving you this kind of like access to the features. Yeah. Okay. So the way that we are going to do that, I don't think that we are going to do it as an example, how you build up the data set, because we already started to do this in here. But at least I'm going to show you how that data set looks like. Yeah. So right now, what I did, I literally took a lot of. I really love Google Earth, and the reason why I like Google Earth is because if I open my browser here, okay, not this one. Okay, they removed it. Okay, so what I had always when I opened a tab, I had an option to have an image of from Google Earth or something like that. Yeah, and I ended up with super, super interesting in a way satellite images. Yeah. From the Earth, yeah, like different mountains or rivers, caves, or super, super interesting, yeah. And for example, yeah. So this, in a way, I just took, in a way, for this example that I'm going to show you, I just took this kind of like screenshots, you know, mountains or something, and use them as a way to generate the data set, yeah. So it's a very then landscape kind of data set, yeah. So here, same, I see, I just love, looking at these kind of patterns. Okay, so let's just minimize this and go back to where I have that data set. So if I'm going here, so mountains, this one, yeah. So you see the screenshots that I had were these ones, yeah. So these are like this kind of Google Earth screenshots, yeah. And then what I did a very similar thing like we did today. Yeah? Only in this instance, I have multiple images. Yeah, they're not just 4 images like we had today, but these are like 52. Yeah, and out of those 52, I generated about 2,000 images. Yeah, but the idea here is, again, I have a very high resolution, 4,000 by something 4K. Yeah, and from that kind of image high resolution, I started to crop and create. In this instance, I created a sort of data set that has a 1024 resolution by 1024. Yeah. Okay. So, for example, this will be if I'm performing this kind of augmentation like we did on the CycleGAN. If we perform an augmentation on these images, the output folder is going to be this one, perhaps, yeah. And then what I'm doing after the augmentation is done, I'm just renaming that to mountains, let's say. And once I have it like that as a folder with these kind of files that are nicely renamed, yeah, then I'm just copying that. I'm just copying that folder, and I'm going into my drive, Google Drive, shared drives, yeah. And then in this case, I have the networks here. And then if you go into the StyleGAN folder, you'll see that there is a folder called dataset. Yeah. So you have dataset, you'll have a folder results, and you'll have a folder StyleGAN. Yeah. So the dataset is where you place the dataset. Yeah. And then the result is where you output the results from the network. Yeah. And then in the StyleGAN, you have actually the actual network, yeah, the script for the network. Okay. So here in the data set, then you just have to copy that in, yeah. So in this case, I already have it here, but just for the sake of showing it, I'm just going to paste it here, yeah, paste like that, yeah. So you see, once you have this kind of high resolution images, you already talk about a lot of gigabytes, yeah. So right now I just have 2,000 images there, and they're already 2.5 gigabytes. Yeah. If you work with more than that, yeah, like 50,000, 60,000 images, just add it up to see how much is that. Yeah. Okay, so that's how you're building up the data set, and that's the structure of the data set. Yeah? It's simply just a folder, and within that folder you have just images. Yeah, that's the structure of the data set for the StyleGAN, at least the StyleGAN that I'm sharing with you. Yeah, maybe there are other versions, other scripts, other like script that other people did that, you know, they have a different structure. The one that I'm sharing with you really has this structure. Yeah? You just have a folder with a name, and within that folder you have a bunch of images that have the same resolution. Yeah, by the way, that's super crucial. You always need to have images that have exactly the same resolution. You cannot have in the same folder images with 1024 and images with 512. Everything has to be the same resolution. Okay. Okay, so let's go back here. So now here we have the same kind of logic, yeah, and you see the file, it's in a way set up in a way that it's easy to navigate, hopefully. So we just run the mount drive, yeah, and we have to specify now or to give the authentication code, yeah. So we click on this link and copy the link or the code, authentication code, paste in, and then press enter. Okay, so now you are connected to the drive again, at least with a StyleGAN in this case. And now we are going to go to the drive, yeah, drive, and then not that one, that's a different thing. Share drives, yeah, and then FIU, deep learning workshop, and neural networks. In my case, in your case, it's going to be into workshop participant, and then you have StyleGAN, yeah. And first, we have to specify the root, yeah, where exactly the main folder is for our network, where we will have also the data sets, results, and the StyleGAN, yeah. So I just right click on that, copy, and then I'm replacing this that way, yeah. And then we have to specify the dataset folder. And in this case, I have to go into the dataset, yeah. And then I'm going to copy, I'm going to use this one, 01, yeah, because the other one probably it's still loading. Now let's copy that one, copy path, yeah. And I'm going to connect it like that, yeah. And then once you have it, then it just plays the cell, yeah. And you continue down, yeah. So now here is the part where we install the, where we make sure we have the correct libraries for this script to run, yeah. So this one, in case that you had that problem, just delete this part, because right now we are just using StyleGAN, okay? And you should be able to see something like this, okay? Now, the next step, it's something that you have to do just once. If you, let's say, once you bring in a new data set, yeah? So every single time when you start to train on a new data set, you have to go through this step, yeah? But that you're doing it just once, yeah? Afterwards, after you already went through this step and you just want to continue the training, or you want to like just retrain, then you don't have to go through this step, yeah? So what this step will do, the StyleGAN is not actually reading images in terms of format, yeah? So it's not reading PNG format, it's reading TensorFlow records, yeah? So what that means is that now we have to look at our data set, which is just a folder with a bunch of images inside. We have to look at that, and we have to convert those images into TensorFlow records, yeah? So to do that, what we are going to do first, we are going to create a new folder, and we are going to call that custom mountains, let's say. And I'm just going to say mountain like 01, let's say, okay? So like that, okay? So what this folder will be, this is the folder where we are going to store those TensorFlow records, yeah? And that's going to be the folder that is going to be the dataset folder for the network, yeah? Okay, so Here, then we have to make a few changes. So we have to specify where the StyleGAN code is, meaning we are looking now for the code of the network, yeah, where the network's code is. In this case, it's this folder, yeah. So right click, copy path, then just control, select everything, yeah, and then replace it. And then the custom dataset folder, which is this one that we just created, yeah. So copy path and then paste it in, just like that. Okay, so now I'm going to play this. So you see you have the option to clean dataset, yeah, or you have the option to not have that marked. So if you don't have that checked, what's going to happen is we are not going to check if you have damaged files, yeah. So if this one is not checked, then we are not going to check if the dataset that you have there has some files that are damaged, yeah. Now, what could go wrong with that is that if you're not checking for damaged files, it could be that you start the training and it's running for a few hours, and then suddenly that damaged file is going to, the network will try to read that damaged file, and then it's going to give an error and it's going to stop the process, yeah? So that's why then it's good to have this one on, because like this, we are trying to open every single file, and we are checking like that if the file is damaged or not, because if we are able to read it, that means the file is not damaged. And once the file is, we can say that this file is not damaged, and we are converting that file into a TensorFlow record, okay? So that's what's happening behind here, behind the closed doors here, yeah? Behind, under the hood, yeah? Right now, you just interact with this part, which is fine, yeah? We don't have to interact with the rest. So now you'll see that the first bar, progress bar that you have here. So we just have 223 images right now there, which is fine. At least, you know, I can go faster to showing you how you start the network, yeah. But right now you see the first bar is really showing like the progress of opening the files and then checking if they are damaged or not. And then the next step is going to be we are going to convert things into TensorFlow records. So in case that this algorithm here, in case that it's finding a file that is damaged, is going to automatically delete that file. Yeah. Yeah, so here you have to be careful, yeah. So you saw that right now I just had 273 images there, although I copied about 2,000 images there, yeah. Now, because we are working with the rule drive, we are always going to have this kind of issue of synchronization. Yeah, we have to make sure that the data is uploaded, yeah, before we actually start this process, yeah. Because otherwise you are going to start a training and you don't have your entire data set for the training, no. So, okay, so right now, for example, it's creating the actual TensorFlow records, and you can already see them here showing up, yeah. So you have custom mountain, TensorFlow records, and so on, yeah. And these are going to be the file that actually the network is reading, yeah, not the actual images.
Daniel, how do you compare, like in terms of the outcome of CycleGAN with StyleGAN? For instance, if we were to test the horse zebra example with the StyleGAN, what would have been the result? And how do you compare these two networks?
So probably with the StyleGAN, probably just have to put them in the same data set, you know, and then hope that somehow the network is going to figure out the relations between, yeah. And then what will happen is that you should have access afterwards, after the network is training, then you have to know how to get in and to just have access to the pattern, let's say, on the zebra pattern or the horse like skin pattern, yeah, you know. So it's not necessarily that the network is going to really give you that answer. Yeah, you'll have to search in a way how to access exactly that level of information. Yeah, because what's happening is like different features are encoded at different scales, different levels. Yeah, like for example, a level of 4 by 4 pixels to let's say 32 by 32 pixels. Probably in that range, in that that domain, you have aspects of the structure of the horse or something, or you know the shape of it. You have it encoded in that level, yeah. But then higher, probably you have to figure out, and you have to search where exactly is the information of the pattern encoded in that network. Once you figure that out, then you can go in and you can just alter that specific, in a way, level, and you say, you know, I want to have the shape of it, yeah. I'm going to affect the lower levels now, and I'm going to say the shape of it has to be a horse-like. But the higher level, which means like let's say 512 resolution, there you have to affect just the texture, the pattern on of the zebra, you know, and probably like that you end up with something that is very mixed or something, yeah. Or you can create also this kind of like because you have access to the latent space, yeah. You can almost like say A plus B, yeah, like create this kind of operation, like arithmetic operations, and have, let's say, an image of a horse, and have an image of a zebra, and just say A plus B, and then you have the result, a sort of horse that has a zebra pattern, maybe. Yeah. So it's just, I would say it's just that the output itself, the network, you'll have to figure out, and you'll have to create some code to figure out how you access exactly that information now.
Thank you.
But it might be that the result is better, perhaps, yeah, only because the StyleGAN is so capable to disentangle those features. All right, so here you see after you run the train or prepare data set, you'll see you have added 294 images, yeah. So that's how this should end, yeah. If you have something like this, you're fine. Okay, and then once you have that, now we can continue and set up our training, yeah. So here we have to again set the training folder, and this is the train folder. If you open your StyleGAN folder, so StyleGAN, not the one with the capitals, but the one with lower letters, yeah. And then you have here a folder called training. So if you right click on that, copy path, and just paste it in here, yeah. So what we are going to do here, just in a moment, you see here we have the training folder. Okay, that's set, and then we have training loop settings. Yeah. So I will say if you have about 2,000 images, 10,000, I think the length of the training, I think it's fair. Yeah. If you have more than that, I will say at least 25,000 iterations for the training. Yeah. So this one, it's something that I kind of I kind of know like where this goes, yeah. But at the same time, it's still a sort of evaluation of I'm letting it run for 25,000, let's say, iterations, and I'm looking at the results and how are those results? Are the results good or not? If the results are not good, probably I'm going to continue the training, yeah. Okay, so let's run this, yeah. So once you have the correct link there, we are going to run that. The training length, we are just going to keep it for 10,000 for now. And then CD. So make sure all these three cells are pressed, yeah. And then we are going to continue down here. And here we have the start training. So now here is the tricky thing. Normally a StyleGAN will take you something like on one GPU, probably it's going to take you from 2 to 3 months probably to train, if not even more than that. If you have 8 GPUs, probably you're going to train in about 2 weeks or something like that, yeah. So it's extremely massive, yeah, and extremely intensive, a StyleGAN, yeah. But here, what we are doing, we are going to work with transfer learning. Yeah, what that means is that we are taking the weights that were already adjusted from a previous network that was trained, yeah, and we are starting from those adjusted in a way weights, yeah. So the easiest way to say it for me is almost like I'm giving this example of if you have a soundboard, for example, and you want to mix the sound, let's say for a concert or something, yeah. If you just bought in a way the soundboard and then you go straight to the venue where the concert is going to be, you'll have a hard time in a way, and it's going to take you a lot of time to fine tune the soundboard specifically to that concert venue, let's say, yeah. But if you already, but once you already fine tune the soundboard, now you can go next day. You can go to another venue, and it's going to take you less to fine tune the soundboard to the new location. Yeah, only because you already had things already set. Yeah, things were already like optimized or more or less adjusted. Yeah, you just had to go to a different venue and slightly adjust a few other things. Yeah, so that will be a sort of transfer learning. Yeah, so the first learning is going to take longer. Yeah, so if you have a network that was already trained and it took something like 2-3 weeks to train, then you can take that network and just extract the weights, those kind of like fine tuning. Yeah, you can extract that kind of fine tuning and just apply it to your data set. And then it's going to take less time to that network to adjust to the new data set than it will take to train completely from scratch. Yeah. So we are going to use then transfer learning, and you'll see that the results that you're going to get here, probably they will take something like 2-3 days until you see some very good results. Yeah. But it's way shorter, yeah, than 3 months or so. Okay. So here, then what's important for us to do is we have to specify the results folder, yeah, where we are going to save snippets or screenshots of the network while training, and also where we are going to output images when we are going to test certain things, yeah. So we have to go here into our StyleGAN folder, and you'll see here results, yeah. So I like to have the results kind of the same name with the data set, again, just so I avoid confusion in the future, yeah. So custom, I'm just going to say this is going to be mountain 101, like that. Okay, so this is going to be the folder where I'm going to output the results, yeah, of the training. So copy. In the case of StyleGAN, in the case of CycleGAN and Pix2Pix, this folder was created automatically, yeah. You had the checkpoints folder where you start to save in a way, yeah. In this instance, we just have to do that manually, yeah. But once we set that folder, then it's fine, yeah. Everything is going to work just fine. Now here we have to specify the actual data set, yeah, that the network is going to read. And in this instance, it has to be the custom data set that contains those TensorFlow records, yeah. So in my case, that data set is this one here, 01, yeah. So right click and then copy path, and I'm going to paste in here, just like that. And then the next one is continue training folder, yeah. So what that means is we are going to take a already pre-trained network and we are going to continue from there, yeah. Almost like the example with the soundboard. The soundboard was already like mixed and fine-tuned for a concert. Now I just take from that setup that I have on the soundboard, and I'm going to continue from there, yeah, to slightly adjust a bit more the soundboard to get the correct sound that I want to get, yeah. So in this instance, then you're going to have this pre-trained output network, yeah. So if you right click on that and you copy path and then input that here. So this is going to be the network that is pre-trained, yeah. So each one of you should be able to see something like this. And that's the pre-trained network, okay? So this is a pre-trained network on faces, for example, yeah? And once you you'll see once you start to run the process. I mean, I can show you like a funky error that happened with one of these kind of networks on this kind of agent-based system. Yeah, digital future occupied my entire wall past year. Okay, so this one, yeah. So this one, it's a very, very, very interesting like result, yeah. As you can see, like it's really, you have this kind of mixture, almost like agent-based system, like strands and this kind of faces, yeah. And the idea is that you continue the training, yeah, from a network that was trained on faces, and then you just change the data set and you ask in a way the network to continue from there on with a new data set, yeah. And you end up with this kind of very, very, very weird, funky like mixture, yeah, between agent-based system and faces. So very similar thing probably is going to happen also in our case here when we are going to combine things like that. Okay, so once you have that, you will have to start the training, yeah. Now, I think that I'm going to get an error here. And the reason why I'm going to get an error here is because this pre-trained output is a 512 by 512 network. And I think my data set right now it's set to 1024, yeah. And probably that's going to create a problem. So to change that, I'll have to go back into my data set and resize it to 512. And then I'm going to be able to take this pre-trained output 512 network and continue the training, yeah. So in case that you also have the same issue here, just know that the problem is that you need to have a 512 resolution data set, not 1024. Okay.
Daniel,
Yes.
this pre-trained output network, is it the multi-agent systems or is the faces that has been?
It's the faces. The faces, yeah. So this is the official. I think it's the official NVIDIA model. The official NVIDIA model that they trained with their 8 GPUs or something, yeah. So that's the pre-trained output that you have here. I think it was NVIDIA who trained this model. So it's super, super well trained, and yeah. So let's see. I'm curious if this is going to work, yeah, because like I said, I have different resolution of the data set. Okay, so while this one is running, so now we are also still faced with the problem that a Google Colab is going to reset each 12 hours, or if you have Google Colab Pro, it's going to reset each 24 hours, yeah. So that means what that means is, okay, what's happening then with the progress that I did in those 12 hours, yeah? Can I continue from where it left off, yeah? And that's why it's quite good for us to have this kind of results folder and have it nicely structured. So once you start the network, you'll see that automatically you have this this folder created. And inside that folder, you'll have this kind of snapshots of the network, yeah, during the training process, yeah. So for example, this one was able to run, I think, about 10 hours or something like that. And after 10 hours, was able to save this, this snapshot of network, yeah. So let's say that my computer reset or Google Cloud reset. So now I want to continue from this 81 network, yeah. So what I'll have to do in that case, I'll just have to copy this, yeah, copy path. I'm going to have to switch it now with this one, yeah. And then the training is going to continue from your previous session, yeah. Okay, but first, when you train it for the very first time, you start with the pre-trained model, yeah, and then you continue with the other ones that are being saved here. Okay. All right, so this one seems to be working. I don't know how, but probably is going to throw an error just in a minute, but no, actually it's not. Okay, that's fine. It might be that actually it's not going to be that able to learn then, because it's a completely different network, 512 with 1024. 512, it's twice smaller than 1024. So that network will have less neurons that you need for a 1024 image. So it might be that it's going to learn something, but it's not going to learn everything because of that. All right, so this is the training, yeah? This is the training process. That's how you start it, yeah? So let's just go into our StyleGAN interpretation now, Google Colab. So this StyleGAN, yeah, is for training. The StyleGAN interpolation, it's almost like, you know, the testing, or once the network was trained, now we are going to output some results from the network, yeah? So if you open StyleGAN interpolation. So now here you have the actual Colab that gives you in a way a bit of access how to play, let's say, or how to control what the network learned, yeah? So you can query and you can ask for specific, in a way, positions in the latent space, and then the network is going to output for you that position, yeah? So what the latent space is, it's a n-dimensional space, and it represents the features that describe an image or a data set that you input to a network, yeah? Everything, all the features that are described in the data set that you input are represented in a n-dimensional space, yeah? So that's what we call the latent space. And when I'm saying n-dimensional, is not 3-dimensional, 4-dimensional, it's really n-dimensional, depending on how many features you have in your data set, yeah? Okay, so the way that we are going to connect here is the same, yeah? We have to connect to the drive first. So we have to connect to the drive. And then once we connect to the drive, yeah, let's connect to the drive first. Allow, copy, paste in. All right, so now I should be able to see my drive here. So I'm going to go to shared drives. And I think all of you should be able to have this results folder. I think I uploaded that result folder for everyone. Where is it again? FIU, this one. Now networks, StyleGAN, and I have it under results. And in my case, I have it like this, mountains. And probably you also have this as mountains, yeah? And this is a network that I just trained, I think, since today's morning. It was something like 10 hours, I think, maximum training. Okay. So now what we are going to do is we have to access this file, because this is a network that trained for 10 hours, yeah, since morning. And now I just want to output some results from that network, okay? So first we have to specify again the StyleGAN folder, and in this case, the actual network, yeah, where the code of the network is. So we are just going to replace that. Now we have to specify the train network, and in this instance, it's going to be this one that I just trained today. So copy, select everything, and then paste in, and then the output results folder, yeah? So the output results folder, you see that is this one, and within that one, we have the custom mountains and so on, yeah? So here, what I like to do is I like to create an additional folder that I'm calling out, yeah? Like that, yeah? So like that, within the results, I know that I'm going to have the outputs during the training, which are these folders, and then the interpolations or after training results are going to be into the out folder. So right click, copy path, and let's paste this one in here, just like that, okay? So now I'm going to run this. So these are the three main folders that you need to connect to the network. to the actual folder of the network, and then the results. Okay. And this one should run like this without any errors. If you have like some errors, then you have to check those. In case that it's saying something that you don't have a GPU, then make sure that you go here to change runtime type and make sure that you have the GPU active. Yeah. Okay. Okay. So now what you'll have here, under here, you'll have a bunch of scripts that are actually doing exactly what I was referring, Benaz, if you recall. I was saying, yes, it's great, StyleGAN, but then you have to find ways to get into and really access all that semantic information that was learned, yeah? And then somehow find a way to retrieve that and really display it, yeah? So here, this part, they're just these kind of scripts that are going in and trying to extract certain levels and certain features, yeah? Or at least to bring certain functionality and to how you explore the space and the results of the network. Okay, so the very first option. So here you'll have to run this then, yeah. So all that script that it's within that cell, within those cells, is going to run, yeah. So that script is going to be actually the script that is going to give us the base for accessing, generate a single image, generate multiple images, and so on, yeah. Okay, so what I'm going to do is I'm going to put these two side by side now, because I always like to see the results in parallel. Oops. Can I minimize this? Yes, it might be hard without Google Colab Pro. It might be hard to work. But you can try to see how it goes. It's just that, yeah, it's a bit painful that you always have to restart, yeah. Each 12 hours you have to restart. That could be painful, but yeah. Okay, so I'm just going to go StyleGAN. Where's StyleGAN? This one. Yeah, my browser is collapsing. Okay. Okay, so I'm going to put these two side by side so that I can see the results folder. So if I'm going to my StyleGAN results and then mountains and out, yeah. So here I should be able to see the results, yeah. So now I can create an image, yeah. And here I can input a sort of position in the latent space, yeah. What that position means, it means nothing, yeah. Like it doesn't represent a specific feature or something like that, yeah. It's just a position in the space, yeah. So you see that that number can be pretty big, yeah. 61 millions right now. No, 614 millions, yeah. The value, yeah. Probably if I'm going higher, it's just that it's going to create an error or something. Or no, seems like it's working even like that, yeah. So let's just wait for it.
What does the truncation defines?
Okay, so truncation in a way operates at lower layers. Let's say 4 by 4, 32 by 32 pixels, and so on. Yeah, and in a way, it's going to affect just certain aspects. Yeah, like maybe it's going to change the shape, overall shape of something. Yeah, but it's not going to affect the details. Yeah, so you can play then with this kind of value, truncation value, to kind of have or affect different levels. Yeah, different levels when it comes to the resolution and what those or what that resolution in a way what those that resolution you have what features that resolution represents. Yeah, let's put it that way. Okay, so for example, this one, if we lower, let's say if we lower this truncation, so here you see that that image was automatically saved in here. Yeah, so here I don't think it's so obvious because of the type of data set that we have. But for example, if you have an object, you'll see that if you play with truncation and the truncation is very low, you end up with objects that are more distorted. It's almost like you're affecting I mean, also here, you see it's affecting the structure almost, yeah. While if you have it very high, you're actually generating a lot of samples that are quite similar, yeah. It's almost like, you know, one that is just operating at higher levels, like higher resolution levels, and other that is operating at lower resolution that are responsible for the structure of the composition or image. Yeah, so for example, this one, yeah, this is one image like that, yeah. So let's create, okay, let's just move on. I'm going to show an example exactly with this kind of truncation. So this is a way to generate then an image, yeah, and that image is going to be saved in here, and you have this kind of high resolution like image, yeah. But let's say one way that I like to explore this, in special when you just train the network, I like to first just output thousands and thousands and thousands of images, and then in a way find a way to explore those thousands of images, yeah, like to display them into a cloud, and then I'm able to move around and see how that latent space is designed, let's say. But just keep in mind that these are extremely heavy. Like if you output about 100,000 images, you're going to eat about 150, 160 gigs of RAM, gigs of space on your drive or something like that. So let's say for now, for the sake of this experiment, let's just run and create 100 images. So what this one does, create multiple. Wait a second. Yeah, here my apologies. This one is supposed to be just create multiple images. Generate multiple images. Okay, so that's supposed to be just that, okay? So what this one does, you can start from which position in the latent space to what position now. So for example, I really want to have a sample like or multiple images taken from the entire latent space, or I just want to take it from a very small range, yeah, a small range of 1 to 100 or more, yeah. So let's say that I want to have it from a wider spectrum in a way, the latent space, so 100 million, let's say. Yeah, 100 million, and I'm going to output just 100 samples of that, yeah, just 100 examples. So I can play this, and now here automatically is going to save about 100 images, yeah. Okay, so it might be that this kind of operations are the ones that are killing my Google Drive. And right now I have also my design studio that it's working with this, and they are all connected to my drive, and they for sure even now they are playing with this and they are generating a lot of data. So probably that's why also our drive is so slow right now. But yeah, here you see that you start to have this kind of results being outputted here. Okay, let's just wait for it. But these ones, they are already interesting. I mean, you'll see we are going to put them into one folder. So everything that has the truncation right now valued of 0.01. And then we are going to put the other ones that have a higher truncation value. We are going to put them into a different folder. And then we should be able to look at 2 of them and to see like higher truncation value really affects just the level of detail, and lower truncation value is actually affecting the structure. Yeah, so as you can see right now, we are dealing with a very wide range from 0 to 100 millions. And like that, we are really able to get a good sense of, the latent space. Yeah, we are really like extracting from all over the latent space. We are extracting these images, and we kind of have a sense of that than to just limit everything to 100. Yeah. Okay, so let's just wait and put this one into. Okay, there you go. Okay, and now let's delete this one for now. So now we are going to create another 100, but this time we are going to create them with very high truncation value. So now you see that some of these sliders, I made them in a way that when you change them, once you change them, it's automatically triggering the cell run. Yeah, so it's automatically starting the run. Okay, so just be careful then. Okay, I'm disconnected from the drive. Yeah, it's showing that it's connecting. Yeah, I think I'm just driving my drive crazy. Right now it's switching off, connecting and so on. Okay, let's stop the others then. Or yeah, this might create some issues now for us. You guys just keep saying connecting, connecting. Do you have the same problem? Okay, but yeah, just a bit, and we are going to be able to cover everything for today. Yeah, so for example, if you remember those kind of images of faces changing shape and so on, and then just changing the details, mostly what you're doing, you're playing with this kind of truncation value. And then also, of course, like searching for similar faces and so on. So let's restart this. Okay. Okay, I'm going to reset this to factory settings. So I have to reconnect again to the entire drive. And then I'm going to run this again. Usually I prefer to do that in case that I see that there are some issues. It's the fastest way in a way to fix things. It's just that you have to redo a few steps. Okay, so running the population videos. And once that is done, then we can continue. I think I'm going to break the spell regarding many of these kind of results. And sometimes, yeah, sometimes these kind of things, they feel very, very complicated. And then you just realize that they're just some very simple tricks. Okay, so right now this one is generating, yeah, it's generating here images. We should be able to start to see them showing up. Yeah, but already you can see the results, yeah, like fine level of detail. And it's mostly we are affecting that level of resolution. So all these are actually fake, but they look so real, yeah. Like these are rivers imaginated by an AI, or this kind of river streams, yeah. No, these are beautiful. They're really, really nice. For just a run test like that, like actually amazing. You can do a lot of things, like if you were to sit down and really control exactly these outputs and, you know, play with that. So yeah, usually what I like to do is I like to go through these two processes first. Yeah, I like to output, to be able to see, like visually, to understand the latent space. Yeah, and then we'll see later. Then I can look at these images and I can pick a few of them and say, okay, I want to create transitions from this type of images to this type of images. Yeah. And then I can say, okay, the seed that has this number and seed that has this number, yeah, and so on. I like this one. This one is super cool. Oh, not really. This one is cool. So I'm just going to start to actually save some values here. 32786 That's a long one. This one is also cool. 39857964. I mean, it's hard to judge. No, it's hard to choose. They're all very stunning. So 88528273. This one looks cool. Now, does it look good? Cool also. It's the same. It's the same that I just picked. Okay. All right. So yeah, I'm just going to pick a few. Yeah, let's try also some that are more dramatic, different. Yeah, maybe this one. So I'm going to choose 98898812755. Okay. I'm going to put all of them in. That's the wrong one. I was supposed to put them in a different one. Anyhow. Okay, so this is about 10 hours of training, which is amazing. Yeah, for 10 hours, it's amazing. Because normally, now here we can see the comparison. Yeah, like this one really affects the lower level. Yeah, just the structure, and the other one, this one, it's affecting the level of resolution. Yeah, like details. Okay. Let's. Okay, so what I'm going to do is now I'm just going to continue here down, and let's say how we transverse in a way by using truncation. Yeah. So I can use these values, yeah, that I saved here, and that's the reason why I saved them, to be able to input them over here. Now, of course, we can also use these values that are there. Yeah. It's just that right now I don't know what kind of image is that 31, 35, 42, 128. Yeah, I have no idea. And right now we are not engaging in an algorithmic process of searching for this kind of similar images or so on. Yeah, we are just right now, yeah, just playing with the videos like that. Yeah. So you have then this kind of values, and if you're looking at if you double click on this, you'll have also a few descriptions there. Yeah, what we are trying to do. Yeah. So we want to start the truncation, let's say from from 0 to 1. Yeah. So it's almost like you're going to have things that are very just affected at the level of structure. Like the image structure composition, and then slowly, gradually move towards an image that it's affected more at the detail level. Yeah, and we can also go on negative with this. Yeah, and if the truncation is negative, then you're going to have images that are very like distorted, almost like unreal. So if we go with something like this, like -1, let's say. And then let's say that we have the increment higher so that we don't wait that much for it, like that. And 24 rates per, yeah, that's fine, frame 24. And let's run that. Okay, so again, it's connecting. Yeah, I think it's something wrong with my drive or something, or browser, because it's super heavy right now. Is this making sense, what I'm showing here? Is it clear, like what these results are? Or do you have some ideas, like, is it like making you think of how you can use it? Not so much. Or you're just writing in the chat, okay. Okay, so interpolation videos, and then let's run the truncation transversal. So we are just transversing now, from a very low value of the truncation to a higher value. Yeah? So we are affecting images. So the first seeds, probably they are going to be affected just at the structural level. And then gradually the other ones, these seeds are going to just be affected at detail level. Yeah, so this is the fun part here with StyleGAN is how do you get to features now, and how can you control those features? I think that's the where the goal is, yeah, where everyone has to mine and try to figure that out. Because once you get to that level, then you start to have some pretty cool stuff. Really, really cool stuff. Yeah, so right now the truncation, I'm just running it with a larger step, just so that we don't have to wait that long for it. Because if you go with very small increment, then it's going to take quite a lot. So here you see there is a video that is generated, and automatically that video is going to be saved here onto our drive. Yeah. So if I refresh my drive here, I should be able to see it in a moment. I should be able to see the video displayed here. And yeah, okay, let's wait. There you go. Yeah, so you have the truncation set, and as you can see, then there are certain values saved also, like the seeds that you used, and then also the incremental step, And also you start from -1 and you went towards 1, yeah. So if I open now this automatically then it's converted into a video, yeah. And yeah, because we have such a large step size, that's why right now this one is so short, yeah, the video. Okay, so the same thing we can do then also with the values that we save here, and we can use those. So this is what you have here. It's an array, yeah. For Python, you describe it as a sort of array. So you have those kind of square brackets, and then inside you just input the seed values, yeah. And it's going to read one by one, yeah, like that. And you'll see now, because I have different seed values, it's going to create another file with a different name, yeah. So it's not going to override that one here. Yeah, so the increment here has really a huge impact on the length of the video and how smooth, in a way, those interpolations are and those transitions. Yeah. So yeah, as you can see, it's going from this one quite fast. Yeah, but if I were to decrease this one, let's say at least twice, something like that, okay, then probably we will end up with something, yeah, it's going to take a bit longer, but it's going to look way nicer. Okay, we are going to go through these ones quite fast. So here, while this one is running, what you have here, you're literally having like a blending, yeah. It's almost like you're fusing like certain in a way feature levels, yeah. So you can control the truncation and you say, okay, we are going to affect, or we are going to blend these images at this level, at the image of at the level of structure, let's say, and then the blending factor that you have. And I think it's working right now in both directions. You're going to have also the first image, which is this one, and also the second one that is going to be blended. Okay, so it's going to save it. And let's see how that will look like. In the meantime, I'm going to start this. Yeah, so we have blending at half, truncation quite high, which means we are going to mostly affect the detail levels. Just play this. Yeah, truncation is going to show up here just in a moment. Okay, let's wait for. Okay, so this is the other truncation, yeah, 0.5. Yeah, so it's a bit much smoother, yeah. So if you are able to increase that step size and to wait for it, then of course interpolation will be way nicer, yeah. Right now it's just 1 second long, which is not really that much. Okay. So here, the way that you'll check this, so right now this one is already blended, yeah, an image that is blending between those two, yeah. But you can also output first the two seeds, yeah, so that you see the images that you are going to blend, and then when you're blending it, you're going to have the output, yeah. So let's see, can we just take these images and just output one image, single image, just to see exactly how that image is. And then the other one, let's collapse this. The other one is this. Okay, so this is the initial image, yeah. So we are blending this one. We are blending it with which one? With this one, yeah. These two, and when we are blending those, we get something like this. Yeah, so as you can see, it's not just a pure blending of things. Yeah, it's not like just morphing them into each other. Yeah, you're really trying to blend them at the level of semantic like information. Yeah, so this is the other one. So if we look at this tree, let's put it like this. Something like that, and this one. Yeah. Yeah, so you see that it's not necessarily just a blending. Yeah, look at this. Yeah, you're taking away this, and suddenly you're morphing them and taking maybe some features from here. Okay, so in that sense, it's not really just a morphing or blending of images. And yeah, the same then. Okay, let's close the blending. And then what you have here, you have also an option then to really specify like interpolations, yeah, like this kind of transitions between different seeds, yeah. So it's not anymore transition based on truncation, like truncation transversal, but it's mostly just we are going from one image to another and so on, yeah. So here, yeah, we can keep these ones or we can use the ones that we already selected here. So I can easily just take this and just input there. And then the same, this one. And so on. Truncation, I'm going to keep it high. We have 30 seconds. That's fine. Yeah? It's going to be very dense, like 60 frames per second. Okay, let's see. And then here you'll see, so here we have that. Yeah, we have simply, we just have a sort of interpolation, which is mostly just a linear kind of interpolation. You go from one to another. But then here you have another one, another type of interpolation, which is more circular. Yeah, it's almost like you're creating these seeds that to go from A, B, C, but then also you have this kind of sort of radial or radius, how far they go off, and or how it's almost like a detour that they take. Yeah, and they go from one to another like that, almost like detouring. Yeah. So then the radius is like how large that detour is. So here, for example, this one is just a simple mathematical function. It's just a sine cosine, yeah, sinus and cosinus, yeah. And you have that, and once you apply that, you know that sine cosine, how you create a circle with those two mathematical functions, yeah. And there you go. You have, you know, this kind of latent spacewalk, yeah, which is super interesting, but has a very simple, in a way, rule behind. And of course, yeah, if you go more deep into this kind of thing, then just imagine what kind of super complicated and interesting paths you can define in a latent space. Paths that have a meaning and they relate to something, yeah. They relate to certain features. They are not just, you know, random circular paths or straight paths to from one seed to another. Okay, so I'm just going to play these ones so that we can have them saving quite fast. And then we are going to look at the results. And I think we can call it for today because we are already 4 hours, 30 minutes, which is way over our scheduled time. Okay, so this one is quite long. Yeah, it has 1800 frames because we have the duration, and we also have quite dense, in a way, frames per second, 60 frames per second. But probably that's what it takes to have high quality results. Okay, so let's see if we see the interpolation video. So sometimes it could happen, just a heads up, sometimes it could happen that these videos or these images are being saved into the root folder where the StyleGAN is, yeah. Sometimes this could happen that, yeah, in case that is not showing up, make sure that you look it up here, yeah. Maybe something got messed up, and then the network is saving those interpolations here. So let's see the interpolation, yeah, this one. All right. Yeah, so that's nice. It was worth it to wait for it. Yeah, amazing. Okay, so yeah, while this one is running, so generate circulation interpolation, circular interpolation. I think this one is also saving here. We can look at it very fast here. Let's see if it's loading. Okay, there we go. Circular. Yeah, so this one, I think it's quite similar with what also Benaz was asking about horse and zebra. So in this case, it's not really that you have just water streams, yeah. You actually have also just mountains, yeah, just top view of mountains. And probably if they are close, quite close as domain, probably you can easily create interpolation moments and have this kind of like zebra translated there to a horse. Okay, so let's see where is this one saving it, and then we can wrap it up. And if you have questions, we can maybe address a few of them. In the meantime, I'm going to also have a look here at the CycleGAN. Not this one, the one that's on the server. Neural networks, CycleGAN, checkpoints, satellite label. Yeah, I'm curious how this labeling works. Not that successful. Yeah, but it has like it has a lot to learn, I assume. But you see, in the case of a CycleGAN, so the translation doesn't happen just in one direction. Yeah, the translation always happens in both directions. Yeah, and I think this is something very cool about the CycleGAN too. Yeah, like right now here you see that we are trying to extract the labeling of this kind of urban element, let's say, like street and buildings, blocks, and green. But in the same time, you see also the other way, like to use this composition that you have here and then force, let's say, the network to generate a new kind of urban landscape. It's actually quite interesting, yeah. And this one is just trained for 14 epochs. So imagine if you have this one proper data set and really train for longer than that, yeah. Yeah, so this one is this one. And it's creating now this kind of tree. So this one is almost like, it's almost like giving you an idea, like, okay, what do I do after I learn this kind of semantic segmentation, or yeah, what do I do with it? Yeah, the idea is that then later you can use the network the other way around. Yeah, you ask network to look at this kind of drawings that you might draw, and then the network will output for you this kind of like roofs of a city or something. Yeah, and you really design then a city from that kind of perspective. Yeah, you're just defining the blocks, and then the texture and everything is created. So yeah, StyleGAN, not StyleGAN, CycleGAN still rocks. It's still quite good. Okay, so let's see, where is this one? Where this one got saved? Linear. Yeah, so for example, see this one, it's getting saved here in this location. Yeah, so in case that you're searching for that, you can always search also in that folder. Okay, so I think that was it. That was it for today.
Thanks, Daniel. So that's a marathon effort. I was just on the chat. I was just reminding people that actually that Alan Turing was a marathon runner. He was 5th in the British Championships of marathon. So I mean, yeah.
Yeah, that's the funny thing about me, is like I'm not the most talkative person when it comes to interacting a lot with people, but don't ask me to talk about things that I like to work with, because I'll keep on talking and talking and talking.
No, it's fantastic. Yeah. It's fantastic. No, it's really fabulous, and we'll put this up on the YouTube channel. The overall objective is, I'd say that we kind of, Philip Bjorn and I had this one discussion. I managed to float the idea that we should have a global classroom, that we basically, the idea of having a separate professor in separate classes and separate groups of students doesn't make much sense. And so this is fantastic. This is amazing. This is amazing. This is incredible. Thank you, Daniel. I'm really impressed by this. Really impressed.
Thank you for the invitation.
Well, I mean, it's thank you. It's all your work, but no, it's fabulous, and I hope everyone here appreciates this. Yeah.
Thank you, Daniel.
Yes, thank you so very much, Daniel.
Absolutely, thank you, Daniel.
Yeah. You should know that you're getting the best here. You're getting the best. I mean, I keep my eye on things, and I got to say that Daniel's really the best you can get. So it's just fabulous. It's a great privilege to have you, Daniel. Thank you.
Thank you. Thank you. Are there some questions then before we conclude?
Well, just to say, I mean, I want my students to go and just to show their work next Saturday. So if anyone wants to come along and see the work that's been produced, and if anyone wants to show their own work as well, it'd be good to it won't take very long. I mean, but just for people to see what's been produced and to share ideas and things. But this has been great. This is one of your best, actually. This last one, I was saying. Turned out very well. Yeah.
Yeah, and it was. I mean, these are super powerful. And if you really know how to play with the data set and really control then the results of the algorithm, it's like, you see, I mean, it's a quite kind of basic data set. I spent just something like few hours, like 1 hour, 2 hours maximum, to just collect that data and then put it together and something like that. Yeah, but it was like something, you know, like a long, like 1 month, 2 months project where you really try to go into details and really control these kind of things. But yeah, even like this, you know, it's like, I really love this ones. I mean, this one, for example, is just super cool. I mean, that level of resolution, those things are super nice.
Yeah, very nice. Very nice.
Yeah.
Well, you've got a fan club now, Daniel. You've got a fan club.
Yeah. So
read things in the chat all over the world, because there are some people watching you in India, in
really?
Egypt,
Okay.
and they were and they stayed up till about 5 in the morning almost for them. So
Ahmed, he's used to staying so late.
Yeah,
like he was also during the Digital Futures workshop. He was also late all the time. So
yeah, he's just my greetings from Cairo. He's still
yeah.
up. There's also some guy from India watching, and I know that also from Romania. So you've had you literally, and of course Marina's in Argentina. So yeah, and who knows who's going to watch it in the recording. So that's fantastic. Thank you so much.
All right.
Thanks. Thanks, Daniel. You can get some sleep.
Yeah, thank you, everyone. I have to finish my annual report. So don't tell anyone. Yeah.
Okay.
All right. So thank you, everyone. I hope you really enjoyed it.
Daniel,
yes.
Thank you very much. You just what Neil said. Of course, it is amazing. I've never seen this before. Thank you, thank you, thank you.
You're welcome. You're welcome.
Yeah. Time to escape before you get a bunch of questions and queries.
Yeah.
Yeah, because I have a few. Hurry, escape.
Really? I was thinking, you know, to create a Clubhouse, like a room in a Clubhouse. I don't know how many of you know about Clubhouse. It's a very, very new app. Like I think something like a few months old, something like that.
I'm just hearing about it now.
Okay.
Let's do it. Let's figure it out. Let's experiment.
Because that will be a way to just talk about, you know, these kind of ideas in general.
Absolutely, I'll make sure to fill it up with questions there.
Yeah. All right.
Daniel,
right.
fantastic.
Thank you so much, Daniel.
So just to say, everyone, it'll be uploaded onto the YouTube channel, and you'll get a chance to look at it again.
Hey, Ahmed.
Okay.
Your camera's on now.
And also just it'll also be on the Bilibili channel. If anyone, there's a whole, there were 20-something watching in China, so there's a whole group there. And also in this group here we have some from China. So yeah.
Cool.
Fabulous. Okay.
All right. Thank you, everyone.
Thank you.
Thank you. Have a good night.
Thank you. Bye. Bye, everyone.